Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, everybody, what's up? What's up, Taco? Boom, 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 boom. Dun, dun, dun. All right. Today is Wednesday. Hump Day. Yeah, we've gotten midway through the week. What's with all the... I got so much stuff going on behind me. Come on, green screens, play nice with me today. There we go. Okay, that's better. Oh, and then yeah, let me start the live stream on Discord. Nice, there we go. Sweet. Yeah, what is today? National... I have ChatGPT. If you ever see my Go Live announcements on Twitch, I have ChatGPT, like, give me a list of what national whatever the fuck day it is. Today's apparently Backpack Awareness Day. What the hell is Backpack Awareness Day? Wait, I'm looking this up. National Backpack Awareness Day. Let's see. Here we go. The third Wednesday of September. And it's used to educate students, parents, and educators about proper backpack usage to prevent... What is this? To prevent injuries and pain. The American Occupational Therapy Association supports the day and encourages everyone to pack light and wear their backpacks correctly, aiming to keep the pack's weight to 10% or less of the child's body weight. I don't know. I remember in high school, dude, we had really, really fucking heavy textbooks that we had to carry everywhere. And I had 8 classes. So sometimes, like, coming to and from school, you loaded that shit with a ton, right? What's up, Evoli? So 10% or less, that seems ridiculous. Because what? Even if I was 150 pounds, that's 15 pounds. Dude, a single textbook is sometimes like 15 pounds. Yeah, that thing weighs like 25 pounds. I agree, Evoli. Like, what? Yeah. What's up, Evoli? How's I haven't seen you in a while. How's the start of school? You can come up and speak if you want. Here, I'll invite you if you want to come say something. You don't have to say hi, but if you want to say hi. I know you were maybe looking at college apps. Oh, what's up, Evoli?
Hi.
Hey.
So I'm still in high school, but the high school didn't accept any of my credits because they were homeschool credits.
That's fucked up.
Yeah, they could have, and I followed the standard for my state and everything. Yeah. They just didn't feel like it because it's work. So
they don't really like to do work. They don't really like doing work there, do they? No. So sorry, what's the solution? What are you doing?
So I took the opportunity to just get my college classes paid for like 2 years.
Nice. That's dope.
So I
How are you
might
doing
get my
that?
Associates of Science before I graduate high school.
How are you getting your college credits paid for? Is your school paying for like dual credit classes? Is that kind of how this works?
Yeah, so they have concurrent enrollment.
Nice.
And because I'm technically homeschooled with them, I don't have to take, and like I'm not gonna get any credits from them to graduate.
Right.
I can just take my college classes at the local community college
Oh, nice. For like hella cheap, right? Or free, basically?
for nothing.
What?
Yeah.
Oh,
for
that's
nothing.
dope.
That's dope.
Yeah, they pay for my textbooks and like all my materials and stuff. I got
Yo.
some free SD cards.
It's some free SD cards. that seems
in
like the
video
ultimate
production.
cheese. That's so cheese. What? You're
Yeah.
getting your whole thing just paid for? That's super nice.
What's
Well-
even cooler is that I get the gym in the package too, and like the esports room and stuff.
Oh, you get access
the
to
free
like
student
the whole.
healthcare.
Yeah. So now you're in like the college system, which honestly, yeah, the gym is nice, right? It's probably a nice gym too.
It is. I've only been there once, but it is nice.
But also some community colleges have really started adopting esports because they can't fund like football teams, right? They can't like do like bigger things, but esports is like a super accessible thing for them to get into. So that's sick. So you get access to the esports cafeteria basically, or the lounge.
Oh yeah, but mine's pretty well funded. It has a few sports teams.
Oh, that's sick. In what league or what?
No, like football.
Oh, football. Oh, sorry. I thought we were talking about esports teams like League of Legends and stuff.
Oh no, I think they have
Oh,
they have that too.
Okay, they have.
Yeah,
that
they
too.
have an entire. They're I mean they're not like big, but they have like a whole sound studio and like video production studio and like a bunch
Nice.
of stuff like that.
Yeah, so you get
And, like,
access to
labs
like
and
a
whatnot.
lot of like equipment and like real world stuff
Yeah.
that you would use for work, but you don't have to pay for it. That's super awesome.
Yeah, I get to use the sound studio. I haven't used it yet because I don't quite know.
Nice.
You can.
That's so cool. Is that your
Um,
is that your goal? Do you want to be like a production person or sound engineer or what are you like aiming for?
I mean, I want to go into animal behavior. I just need some extra credits,
Okay.
and it sounded neat.
It is super cool. And you never know that hobby could like develop into like a nice little side hustle, you know? Start doing
Yeah,
like
also,
some
I
production
already
work on
do
the side.
stuff with that anyway.
Oh, okay,
so-
cool. Yeah.
Yeah, like I
So-
got paid for commission-based like video editing sometimes.
Oh, sick. Okay. Do you use Premiere a lot? What's your go-to?
I use DaVinci, but I'm learning Premiere for the class.
Ooh,
'Cause
okay.
Also included in my classes, I get Adobe Suite for
Oh,
free
wow.
the entire semester.
I pay those fucking Adobe gods like $700 a year for their stuff.
Yeah, I get
It's
it
terrible.
free.
Wow.
The
It's
entire
such,
thing, like Animator,
you get the whole suite. Yeah.
Premiere, yeah, I get the whole
Premiere,
suite. I don't
Illustrator.
even need it for my class, but I get it. Photoshop.
Photoshop, yeah. No, they've turned everything into a subscription model now. But this is the advantage of like being in college, is especially if you have that .edu email, is you get access to so many discounts for so many different things, which is so useful.
Yeah, well, the thing is, just use DaVinci. Honestly, I like DaVinci better than Premiere, and it's free.
I can't use DaVinci because I'm used to Premiere. That's the problem. I feel like what
They're like the same. They're the
no
exact same.
the workflows are so different. Like
No, they're so similar.
I've tried to use DaVinci and it was painful. Like I
It was
could
like the
not
exact
figure it out.
same.
I don't know. I see it and I started losing my goddamn mind. And it was just to do like some easy levels editing for my cousin was doing a short film or something and he needed someone with some sound background, which I do production and stuff. So I was like, yeah, I can like go in and at least put a limiter or whatever on your audio tracks. But then I was like, all right, cool, just send me like the Premiere file. And he said, oh yeah, we use DaVinci. And I said, oh shit. I know, because everyone's broke and like DaVinci is free. But I shit you not, I was so frustrated. I figured it out. I did figure out how to do it, but at the end of the day I was like, okay, just let me go back to Premiere at least.
using both of them. They're just the same to me.
Maybe they've changed. This was probably like 3 or 4 years ago when I was using it, and I was just like, I can't use DaVinci
got
anymore.
a few updates.
Okay, maybe it's better now. What's up, Drew Taylor? That's super cool. Awesome. So you're technically a junior, maybe in high school, or it's. I mean, what do you have to keep doing for high school? I'm curious.
I'm technically a senior this year.
Okay. And then you're just gonna rack up enough college credits that you can basically, have an associate's degree when you graduate.
Yeah, and then I'm gonna use Modern States to CLEP out of the stuff that I need to, because Modern States will give you a free CLEP voucher.
Oh, wait a minute. I know about this.
Yeah, tip there for people. You can take free college credit classes, whatever you want to, by CLEPing out of stuff online with Modern States. They'll give you a free voucher.
Did you tell me about this? Were you the one that showed me this? Yes. Yeah. I think I did tell some people about this, but yeah, for those because it's been a while, but for the new people watching on my channel and stuff, this is, a very super awesome way to get
entire degrees off this.
Yeah.
You can get entire degrees off this.
I'm confused who the fuck funds this. I'm like, great, love it. Whoever's paying for this.
The government does.
Okay,
I think it also might be Harvard.
W government.
Yeah.
But yeah, you can get credit for all this stuff because it's called CLEP, right? It's like a testing out exam or something. Yeah, CLEP exams. Yeah. Yeah.
So basically, you complete a certain amount of the course, and they'll give you a free voucher, and you can turn that voucher in online or at a local testing facility, and then you can CLEP out for free. And if you pass the test, then you get your college credits.
That's sick. Wow. Nick says, can you? Yeah, here, I'll send the link to you, Nick. Yeah, here you go, man. Yeah. That's super awesome.
So yes, I highly recommend it because you can do it on the side as well.
This isn't a scam. Like you've used this. Okay, sick.
Yes, I've used it.
I haven't
done the CLEP thing yet, but I know that other people have. Like I know people who have.
I never even heard of this until you told me about this, and I thought this was like so cool. I was like, what? You can get all this because usually these things are very expensive. I mean, to take the SAT is like $100 or something, right? Like AP exams are $80 a pop or some shit, right?
Mm-hmm. And even CLEP by itself is like $140 per exam if you don't use a voucher.
But Modern States just gives you these vouchers. That's super dope. Wow.
If you complete the course, you put the voucher in, you email them, and then you put the voucher in the College Board website.
Someone in my chat on Twitch says Hank Green is also doing a similar thing with Arizona State University. Let's see. I think he has something called Study Hall.
Yeah, but Modern States is for everywhere because like Florida also does the same thing.
Oh, bro, this is the Crash Course guy.
Yeah, that's Hank Green. He's the Crash Course guy.
Oh, I know this.
He also wrote a book on tuberculosis. Love Hank Green.
He wrote a book on TB. What? Just for fun?
No, he made a book called Everything is Tuberculosis, and he just like related like Ariana Grande and stuff to tuberculosis.
Oh, wow. That's super sick. What? Excuse me. What? I need to like look this up. Hank Green. Hank Green tuberculosis.
He also made an ADHD focus app, which is very nice. Would suggest it.
Everything is tuberculosis. Okay, I'm gonna add this to our list of links to like check out. Okay, cool. Yeah, Lemafau, what? Yeah. Okay, awesome. Love that. It's sold out apparently. His tour is sold out. That's super cool. Is he coming to LA?
Yeah, it's
oh damn.
Let me find the app name for you. It's called Focus Friend, and basically you just like put it on your phone, and the only thing that stops if you click off the app, then your little friend gets really sad and depressed, and you lose all your money.
Oh, bro, this is like the it's like the Duolingo. You know when Duolingo, that fucking bird's like, Duo is so sad that you won't complete your Spanish lesson today.
No, but like, it's
what's it called? Study Friend? Sorry.
Focus Friend. But it's not that because like it's like you're knitting or something, and you get stuff to like customize your room.
A cozy gamified focus timer. Wow. So this is your friend. This is your bean friend that you have, and you have to keep him alive by focusing.
No, you don't have to keep him alive. You just click it whenever you want to, and you can customize stuff.
Oh my god!
It keeps you off your phone. Not that I actually ever use my phone very much.
Yo, what? Yeah, Nick in my chat's like, I'm checking this shit out, dude. Yeah, hell yeah, this is dope.
Yeah, I suggest it. I only use it when I'm like taking my dogs out or something to motivate myself because I don't really use my phone.
Oh, someone in my chat told me that the Everything is Tuberculosis is written by his brother, John Green.
Oh, it's written by John Green.
That's cool.
Listen,
I mean, still.
I get them confused. They look nearly identical. Okay.
Oh, do they look the same? That's gonna be a mindfuck for me.
One looks slightly buffer.
Wait. Is John Green in Crash Course or is it Hank Green? No, I think Hank Green is Crash Course. This guy looks a little bit more like rough around the edges. John Green. Yeah.
Yeah.
He's an author, a vlogger, and a philanthropist. Cool, man. Wow. But yeah, it looks like he has a similar thing to whatever the modern states thing. Study hall. I'm glad people are doing shit like this. I'm glad there's some goodwill happening in the world, right? Yeah. Fuck yeah. The app's on both, Nick, the study friend. Or I saw it on Android, and if it's on Android, it's got to be on Apple. Like,
yeah. But the reason I'm actually here today is because I'm in statistics now.
Do you need help with statistics? Can I help you with statistics?
Yeah, I put it in the help screenshots.
Love it. Okay, cool. That's awesome. I love that. Yes. Oh, sweet. Fuck yeah. Okay, cool. All right, let's start the stream off, and I'll help you out with some statistics, okay? All right, let's roll. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out with math homework, science homework, all sorts of fun things. We're going to kick today's stream off with some stats. You don't like stats, Evoli? I think stats are really cool.
It's not the worst math class I've had, I will say that.
What's the worst math class you've had? Tell me the worst one.
You know, this is kind of dumb, but Algebra 2.
Algebra 2 is low-key kind of useless. I will agree with you there.
Algebra 1 was interesting at least, but Algebra 2 was...
Algebra 2 just feels like a rehash of shit. You're just like, what's going on? What's up, Omega? I think Omega can. He's in my
physics.
Twitch. He teaches stats. Sorry, what'd you say, Evoli?
Huh? Oh no, I was just saying, and then they start adding physics to Algebra 2, and it's weird.
Oh, really? They do that? That's interesting. They start adding physics to Algebra 2. I didn't know that. I was like, I had to.
Yeah, well, not physics quite, but like geometry and stuff, like calculating distance and whatnot.
Yes. Well, when you start doing like arc length and shit, or like Yes, I agree. That can be kind of annoying. I just think Algebra 2 is kind of because it's just a rehash of special topics for algebra. So
yeah, I actually kind of liked physics.
Good. I'm glad you like physics. Physics is awesome. I'm a little biased though. Omega Kent says we're starting strong today, calculus, and so yeah, we're gonna do some stats here first, and then I think Sibley has a good vector calculus question, and then if anyone else has questions and you're watching us on TikTok, Twitch, YouTube, or Discord, you know where to go. Just go to that website down there, actualdiscord.com/submit, and you can send us a screenshot of your question. We'll do it. All right, let's see. Using the weighted mean, find the average number of grams of fat per ounce of meat or fish that a person would consume over a 5-day period if they ate these. Oh, okay. Weighted mean. I see. So weighted is like how prevalent something is. It like every entry is not equal. So if this was an evenly weighted mean, Evoli, I would just add these all up, right? I'd get a number. And then I would divide it by how many entries there are, right? Which is 1, 2, 3, 4, 5. I would just divide it by 5. That would be an evenly weighted mean.
Mm-hmm.
Okay. Cool. So for instance, because we eat more tuna, this thing should affect the mean more than the fried chicken drumstick, because I didn't eat as much of that. So, okay, how to weight. What I would do, I would figure out what the total number of ounces are here. Someone may tell me this is wrong or something, but I don't know. I think this is what I do. I take like the percentage of this out of the total, and then I multiply it times this. I think that's how a weighted mean works. Yeah, wait, Jeff says total fat per item divided by total ounces. Yes. Yeah, per item. Yeah, okay, cool. Wait. Is it fat per item? Or I think it's this number. Wait, one second. No. We want to know the average number of fat per ounce. So the shrimp total is 9.9. Do you really do that? They want fat per ounce.
I mean, I have my chapter notes for weighted mean.
I mean, the way I would do it, so I would add up what all these numbers are. I might be wrong. Well, we can consult ChatGPT afterwards just to see if I'm like correct. But I would add all these up. So that's going to be 3 plus 3, 6, 8, 10.5, 14.5. So there's 14.5 total ounces of food, right? Getting eaten. And so if I want like the weighted average of these things, I think I want to do this. I want to do 4 over 14.5 times 1.75 plus 2.5 over 14.5 times 4.4. So like I'm taking this number, dividing by this, and that's like the weighting. Oh, it's the same calculation. Thanks, Jeff. Okay, cool. This is just what makes sense in my mind. I take this times this, plus this times this, plus this, so 2 over 4. And I'll explain how this works, actually. You know where this will make more sense? If we think about how you guys have grading rubrics with like homework and quizzes. Maybe that'll kind of show you how this works. So 2 over 4.
Are you basically doing 2.5 or 2.5 times 4 or are you dividing 2.5 by 14.5 and then multiplying?
Good. It's the same thing. If I do 2.5 times 4.4 and I divide it by 14.5, algebraically that's the same thing. But what I like to think about is this is the weight. Where this is really fucked is that we're dealing with actual weights, but when we say statistics weights, we're saying like how important it is. So it's not like a physical weight. This is like the weight, or I could say like the importance of it, right? Yeah. And so the important,
like a grading thing.
Good, yeah, like grading, exactly, yeah. And yeah,
I did that on a previous problem, and I'm pretty sure I got it right. Nice. I just don't quite get it how in relation, because it's different in this one. So
yeah, in this case, the weighting is by the weight. It's the ounces. It's so annoying. Like, but this is. They're saying you ate all of this stuff in 5 days, which, Jesus Christ, that's a lot of like fish and meat and stuff. But so based on everything you ate, which was 14.5 ounces of stuff, or let's say just of food, sorry, because I hope we're not just eating microplastics these days, of food, that the tuna, which had this fat composition, that got eaten for 4 out of the 14.5 total ounces of like your consumption. So this is a pretty important thing for like your average, the average amount of fat content that you're eating. This is like the importance of it. Does that make sense? I sometimes I go around in circles trying to explain myself, and then I'm like, oh no, what did I do?
No, I think I get it.
Okay. So then that's times 3, and then this one would be 3 over 14.5 times 3.33. I believe so. I believe that's what we get. Again, we'll throw it in the chat. Do you have the answers for this one too? That actually sometimes helps.
No, I don't. This is homework.
It's okay. ChatGPT will get it. ChatGPT, especially ChatGPT 5. If you use the big, powerful version of it, I've yet to see it get something like this wrong. It's pretty bulletproof. But let's see. Let's see what we got. So we got 4 divided by 14.5 times 1.75. Cool. Oh, 1 second. Let me make sure my chat's working on YouTube. Where's that? There you go. Sorry. Select live sources. What's up, Maria? Oh, Maria's asking about physics. Yeah, I'll do physics in a bit. If you want to send a screenshot, I'll do it, Maria. Why can I not add any of my live streams? My live streams are up. Oh, man. Okay, let me activate this one at least. Okay, solve the CAPTCHA. There we go. Okay. All right, TikTok chat's working now. Nice. Displacement is final minus initial. Correct. Yeah. Final position minus initial. And then, one sec, I'll put the... Where's my YouTube chat? Okay, perfect. There we go. Oh. Does that say we're live? We should be live. What the hell? Okay, I'll figure that out after this question. Let's do this one. All right. 4 divided by 14.5 times 1.75 plus 2.5 over 14.5 times 4.4 plus 2 divided by 14.5 times 2.5 plus 3 divided by 14.5 times 3 plus 3 divided by 14.5 times 3.33. Okay, cool. So that gets me an average of 2.9. Okay. So here we say average is equal to 2.9. And then that's going to be grams per ounces. Okay. Is that what you got when you did this? And then here I can... Let me drop this in chat.
I'm not gonna lie, I got halfway through the problem and then kind of gave up because I wasn't quite sure what I was supposed to be doing.
Oh, that happens all the time. I totally get that, especially because you don't want to be like wrong, right? I hate going down big long paths and then you're like, I don't know about this. Here, solve this. We're gonna put it on the fast, on the really heavy one. It's called ChatGPT thinking or something. I don't know. As opposed to like not thinking. What happens when AI doesn't think? Okay, while that runs. So, for everyone else who's watching who wants to know like how weighted means work, it's kind of the same thing. Let's say, for instance, you had quizzes, homework, and tests. These are usually how like your grades are broken down in class. So sometimes they'll say, oh, quizzes are going to be 30%. So quizzes would be like 30 points. Homework is then, I don't know, 20%. So we say 20 points. And then tests are 50 points. So if you want, and then let's say like your grade, your average grade in your quizzes, let's say is a 94. Let's say your homework is like an 81 because you keep forgetting to do it. And then let's say you clutch and lock in on the tests and you have like an 89 average on the tests. If you wanted to calculate what your grade is, right? This is also a weighted average where we would say like the total points you can get is equal to 100, right? 30 plus 20 plus 50. So if you want your average, it's going to be the weight. So 30 points out of 100 times 94 plus 20 points out of 100 times 81 plus 50 points out of 100 times 89. And that will give you like a final grade. And that's how you can do final grades calculations. I know students do this all the time. They try to figure out like, hey, what's my score in this class going to be? That's how you do it. Okay, let's see if ChatGPT gave us our answer though here. 2.9. I like that. That's what we got as well. I'll take it. Cool. Okay, so that was correct, Evoli. Yeah?
Yay.
We love that. Awesome. Sweet. Did that make sense and stuff? Yeah?
Yeah, I think so.
Yeah. Cool. Okay. Did you have any other questions about stat stuff?
I do, but I also don't want to take up your time.
No, please do. You can take up as much of my time as you want. Because, yeah, I only have one other question. CK submitted something. Looks like a precipitation. I'll do your question, CK, in a bit. Yeah, if you want to send another one, Evoli, I'll go through it, and then I'll help someone else out, and then if you just keep sending screenshots, I'm going to be on for at least the next 2 hours, so You can just like keep sending stuff. Yeah.
Okay, I have this one right here, but I am not understanding z-scores like at all.
Awesome, please. Yeah, I love z-scores. Yeah, Jeff says don't stop, because if you stop now, we have to do physics. Don't stop. Jeff just wants me to. Jeff loves when I do math, and it's.
Okay, put it in the help screenshots.
He was very sad over the summer when I was teaching a physics class at UCLA because I had to keep doing like physics office hours all the time, and Jeff's like, "Get this physics out of here." I was like, "Bro, this is what's paying my rent." Maria says, "I'm gonna need your help with physics soon." Of course, Maria. Oh, you bombed your test on acceleration? Oh, I'm sorry. Your nerves got you? Don't worry, that happens all the time.
Checking out Flipping Physics. Flipping Physics is really good.
I know the guy from Jonathan from Flipping Physics. I've worked with him actually.
Yeah, I recommend him. He's super cool.
Yeah. Exactly, yeah. So here, Maria, I'm going to send this to you if you want to, with Billy, Bob, and Bo. His thing is kind of funny, but check this out if you want, Maria. This guy, we've worked with him before on, like, authoring content and stuff, but he's also cool. He has some really good videos. Yeah, we made, we did an AP Physics review course together. This is back in, like, 2023. I tried to get him on my podcast here to, like, interview him, and he kind of just said, like, yeah, no, dog, don't think it's a good fit for me. I was like, what? I was like, okay, I get it. I know I only have 7K subscribers. You have 130, but, like, come on, man. I think it'd be cool to have the students ask you questions, and, like, you're a legend to a lot of my students.
You got me through physics.
That exactly. Wouldn't you like to ask some personal questions of Jonathan on a podcast on this live stream? I think it would be cool.
I don't have any personal questions for him, but that would be cool to see him.
It would be cool to see him, right? Yeah. I don't know. Maybe when I get to like 10K or something, he'll take me seriously, and then I'll get him back. Anyways, okay. Let's do this. Sibley says, "Oh yeah, Flipping Physics is hard to understand." Yeah, it depends. Like he resonates with some people, and he definitely does not resonate with some others. So yeah, it's.
I've had to watch it on like 1.5 speed before. I'm not gonna lie.
Yes. No, I agree. And that's the beautiful thing about YouTube is you can like slow down. Yeah. OG says, I love pure math until real analysis. Yeah. I never took real analysis. I only took complex. Let's torture Jeff and go into a random trig page on the internet and answer the first 5 questions. No, Jeff loves trig. Trig is fine. All right. A person reads on average 28 ebooks a year. I don't read 28 ebooks.
I do.
Dude, what?
I read more than that.
I'm still stuck on Dune. I'm still stuck on Dune.
I probably read like 50K every 3 days or more.
Reading is important, honestly. My parents forced me to read books, and I'm glad they did, because I don't think people read enough books these days, for sure.
I read too many books.
There's no such thing.
To the point of where I got told I had an addiction to books and not phones.
Dude, I mean, out of the things to be addicted to, I would take books over phones any day. I needed to read
less books.
Those people should not be in your life, unless they're your parents, but it's okay.
Oh, no, it was because I wasn't doing my other schoolwork, because I was just reading.
Oh, okay, yeah. If you're reading too much and not doing your other stuff, then yeah, if you're forgetting to eat or some shit, yeah.
Eating is pain.
You can't torture Jeff with any math. He feeds on it. He only becomes stronger with every equation, lol. Okay, z-scores. Let me explain, like, what a z-score is. Like, or what do you think a z-score is? I'm actually curious.
Isn't a z-score kind of like the standard deviation away from the mean?
Exactly. Yeah. It's like the normalized standard deviation. Yeah. So here we go. The standard normal distribution. Right. So the
empirical.
Good. Yes. Yeah. There's the rule, right? The 33?
Empirical rule.
Fuck, was it 6? I think it's 65, 95, 99. Is that what it is?
There's a few like decimals in there, but close enough.
Whatever, it's somewhere close there. But yeah, so z-score is equal to this, right? It's equal to x minus mu all over sigma. People like just memorize this equation, but I don't think they understand where it comes from, right? X minus mu, this is just saying like how far from the mean are you, right? So x is like an individual data point. We say how far from the mean. And then dividing by sigma is saying, okay, that distance you're away, how many standard deviations is that? That's what a z-score is. It's telling you, so a z-score of 1, like a z of 1, tells you that you are 1 standard deviation away from the mean. And it's super cool. Oh, it's 99.7? Yeah, there you go. 68, 95, 99.7. Thank you. Yeah, that's what it technically is. Right, and then standard deviations are cool because that tells us how much spread or how much like wobble there is in our data. So something with a high standard deviation means that the numbers are all over the place. An example of standard deviation being high, that's a good one. What was something that would have like a high standard deviation? You actually understand statistics? I do, yeah. Well, until like I'm asked the question of what's a high standard deviation. I don't know. How about people rating other people in terms of attractiveness? I think that's probably a high standard deviation because people have like wildly different tastes on things. So some people probably like noses or ears or eyes or whatever. I don't know. So that could be like all over the place. Something with a low standard deviation means that there's not much variation in that number. So for instance, rating what you think of the 3rd Harry Potter book is, that would have a low standard deviation because it's a great book. Examples. So here we say the standard deviation is 3. Find the corresponding z-score for each raw score. Oh, this isn't bad at all then, right? You know how to do this. So z, so the raw
you
score.
Just showed it.
Yeah, the raw score is just this. Yeah.
It's just data value minus mean.
Good.
And then divided by standard deviation.
Yes, exactly.
My man.
So this one would be -1, right? 36 would be 8 books over, but then each standard deviation is 3 books. So this would be positive 8/3, right? This would be -2. And then this would be -4/3. And then this would be positive 4/3. Yeah, not bad at all. Yeah, okay. I think what eventually gets interesting with this is asking the question, for instance, of like, what percentage of people read, let's say, like between 22 and 36 books. Do you know how to do this?
No.
Okay, let me show it to you because it's going to come up next. Okay, so this z-score, right, has percentages. Like, this is the cool thing about the z distribution. Do you know what happens if you add up everything within the bell curve, the z distribution? Do you know what you get?
Isn't it like 0?
You get 1.
1, okay.
If you add up the total area of this, you get 1, which means there has to be 100% chance, basically, of something happening. If you split it down the middle, right? Let's say in this case, this is what the average. I always like to say, like, for instance, this is the real score, right? Whatever percentages, and then I like to say, okay, what's the real score? Or I guess they call it the raw. They call it the raw score, which is like, what does this correspond to in real life? Well, a z-score of 0 in real life corresponds to 28 books. Okay. So if you wanted to figure out the proportion of people that read less than 28 books versus the proportion of people that read higher than 28 books, it would be 50-50. Because this area would be exactly half of the total area. And the area underneath this curve tells you the percentage chance of that thing happening.
Yep,
So
I think I actually have a question like that on my thing.
Oh, I'm sure you do. Yeah, this is the next step. I've taught enough statistics that like I know exactly what's the next thing they're going to ask you. So, for instance, 1 standard deviation down, that was 25 books, right? And then 1 standard deviation up was 31 books. Yeah.
How can you tell that? Like, is it? Oh, you just like do.
Because I know a standard deviation, right, is 3. So 3 books higher is 1 standard deviation higher, and that puts us at 31 books. Or if you wanted me to calculate this, right? Yeah, do you see how I could do like 31 minus 28 over 3? And that equals 3 over 3, which is equal to 1. And that's a z-score of 1. Okay, perfect, cool. Jeff says, if I'm being whiny, I'd point out that 10 standard deviations below makes no sense. Correct. You can't have negative books read. What happens if you have negative books read? Did the books like read you or something? Like, does the book just like
you've been sucked into a dichotomy void.
Yeah, it's like that scene from Alien or something where like the book just like grabs your head and just like starts sucking your soul out or something. Okay. So if I were to ask you, Evoli, for instance, like what percentage of people read between 25 and 31 books, okay? So I'm thinking like out of the population, like what percentage of people read at the least 28, but at the least 25, but at the most 31? What do you think that answer would be? And the empirical thing actually helps you here a little bit.
Would it be like, so would it be like 15.9? Is
close. So let's remember that 25 is down here, right? That's -1 standard deviation, yeah?
Mm-hmm.
And then 38 is +1, which is here. The percentage of people that do this reading of 25 books to 31 books is this entire area. Okay? Now, this thing shows us what all the different percentages of these different bars are. Yes, you do need the Z value, but we do know that 25 books is -1 for Z, or 1 standard deviation below, and 31 is 1 standard deviation above, which is, yeah, +1 is Z. I'll show you how to use a Z table, but let me show you the empirical way first. This empirical rule that we learned earlier, which I think it was 65, 95, 99.7, this tells me the percentage of area, or the percentage of people, or the probability of something being from 1 standard deviation below to 1 standard deviation above. This tells me for ±2 standard deviations. This tells me for ±3 standard deviations. Oh, it's 68? All right, sorry, my bad. Yeah. Okay, so do you have questions about the Evoli?
So do you have to like calculate the percentage in between?
Yes. Which I'll show you how to do it with the Z table. This is how to do it with a cheap little hack, okay? Which is that if the range you're looking at is 1 standard deviation below and 1 standard deviation above, this total area here is 68%. Okay? You can read it if you want to read the individual areas on these bars, for instance. So this is like 15% plus 15%, that's 30, plus 38%, because that's 19 times 2. 30 plus 38 gets you 68. And that's... Okay. Yeah, cool. Let me show you how to do it from a Z table. Right, Popoli is like, use the Z table. Because, yeah, this is a thing that comes up. And then I'll show you how you can do it in your calculator, actually. It's even easier. If you get like a TID... Do you get to use a TID4 or something equivalent in your stats class?
No clue what that is.
You know what a calculator is, right? Yeah, like
Are you
this
talking
thing.
like a Texas?
Yeah, the TI Texas Instruments, like this gold one here.
I don't know.
Yeah,
I don't
this
quite
thing
know.
this thing has so much stats on it, like just built in. It has all these statistics stuff built in. It's so nice. People don't realize how much statistics is on this. Are we going to be using the normal distribution? We are. We definitely are going to be using the normal distribution. I'm going to show you where it comes from. I need the tables, though, but I want nice tables. Where are my nice tables? Because also, like, it depends. You have to know how to read certain tables. Certain tables are formatted different ways. Because sometimes they do, like, area to the left, area to the right, or whatever. It's kind of annoying. Let me see. Baiju usually has good stuff. You got some tables? Yeah, you do got some tables for me. Thank you. Why is this one colored yellow, but this one is monotone? Okay, whatever. This is statistics. Yeah, here. Okay, so let's show what happens. Okay, that's part of the table I need. I need this part as well, please. Okay.
What would you do if you didn't know the standard deviation?
You'd have to estimate it. So, you can estimate it based on the number of samples you have if you really have to. You can, and in that case, you have to use, instead of z-scores, you have to use what are called t-scores, which are based on the number of samples in the data you came up with. Right? When this person figured out that 28 people on average, that people read on average 28 books per year, how do you think they got that data? Did they ask every single person in the world how many books they read? Probably not.
I mean, they should, but
they should.
They don't.
But that would take a lot of time, right? So what they did is they took a sample. So they probably went to a college campus and they asked like 100 kids, "Hey, how many ebooks do you read?" And based on that number, they can come up with an estimation for what they think the whole population does. And this is where statistics comes in, because statistics tells us with what level of certainty I can say based on like how many people I asked. It's really cool.
But that would be super skewed because different population or different samples of people like read different amounts.
100%. And this is where you have to do what's called an SRS, which is a simple random sample, which means the population you're trying to describe, you need to have a random sample of that population. So for instance, if you're trying to figure out what percentage of, if you're trying to figure out how many ebooks college students read, you wouldn't go to a nursing home and start asking those people how many books do they read, right? Because the people in the nursing home, that sample is not representative of the population you're trying to describe. If, again, you're trying to do college students, it makes sense to go to a college and just ask 100 kids. But then you need to be random about it, right? You don't want to like post up by the English department and only ask those people. You want to like randomly pick everybody at the university. You want to randomly pick people. If you're trying to get it depends what you're trying to describe, right? Otherwise, you're right. Things do get skewed. Yeah. Okay. So this is a Z table, Evoli, okay? Which looks scary. I know, right? You're like, what the hell are all these numbers?
It looks like a coding document.
It does. You know what this looks like? And I'll show this later to people. They have things where they do. So before calculators and things, we used to have books, and it was like a book of random numbers. So if you wanted to do a random number generator, you would open up this. That. Oh, you know these? Yeah, they're super funny. Yeah. Yeah.
Looks like a phone book.
Yeah, they're ridiculous. Or like a table of integrals. It's a whole thing. They're relics of a time long ago. Which, yeah. Okay, so do you see how this looks like the same normal, the bell curve we have here, right?
Mm-hmm.
So what this table allows you to do is that given a Z number, it'll tell you what area is to the left of that Z number. Okay? They usually say this, they say this is like the probability that like Z is less than X is kind of like what they say. This is a way to write it. So, what's up, Reki? 6'7"? Oh no. You kids with 6'7" these days, you guys gotta stop. So, what I'm gonna do first. It
doesn't even mean anything.
It doesn't. It's the ultimate meme, right? Because it's nonsense. I'm gonna look up what this this Z number is. So I need the Z number -1, okay? And from that, so you look on your table here. This will get you to the first decimal place. So you see how it's like Z -3.4, 3.3, 3.2. We want to come all the way down here to -1, okay? And then this column is like the second decimal place. So if my Z score was, for instance, like Z was equal to -1.0 I don't know, like 0.6, I would technically come down to this row, minus 1.0, and then I would find the intersection with 0.06. This number right here would be the area associated with z is equal to minus 1.06. That's how the table's read.
Okay.
Okay. So minus 1.00, that's this one. Okay. And so that tells me that there is 0.1587 to the left of that. Okay. So let's try to like draw real quickly, like a little bell curve, what this would be. So I have my z-score here at minus 1, and I know the area to the left of that is 0.1587, okay? So this right here is going to be 0.1587. Now I'm going to look at what the area is for z equals to 1. So we're going to look at this table, because I have to now see on the right side of the z's thing. Technically, these things are symmetric, so sometimes they only show you one of them, but I'm going to show you both. So here, again, z-score, we're looking for 1.0, and it's 1.00, and then that's 0, so that's 0.8413. Okay, so out here at plus 1, that's an area, going back this way, of 0.8413. Okay. How do you think, Evoli, I get the area in between the two? So if I know the area from here going back, and I know the area from going here back, how do I get the area in between the two?
Do you subtract?
Exactly, yeah. So I take this big pink number, right? And then I subtract the green, and that gets me what's left in between, okay? So we do the same thing here. Exactly what you said. You do 0.8413 minus 0.1587, okay? And that's from our little z table thing here. So then if you go to your calculator, we can do that. So 0.8413 minus 0.1587, and that gets you the same answer, 68%. I mean 68.2%, but yeah, basically just 68%. And that's the same number that we got from the empirical rule here, which was just cute when something is exactly plus or minus 1 standard deviations. Yeah.
Cool.
Yeah, right? So that's how you can do it for any range. You just need to figure out what the z-score is of your low range, what the z-score of your high range is, and then you find the areas associated with those z-scores, and then you subtract the bigger one from the smaller one. And then that tells you the percentage probability of that happening within that range. Yeah.
Okay.
Yeah, cool. I think you can also do it on your calculator here. I think if you go to stats, calculate, where is it? Or maybe it's under tests. Z interval? Is it Z interval maybe? Maybe it's Z interval. Stats. Oh, that's a confidence level. No. What is it? Jeff, do you remember what it is for getting z-scores on this? I forget where it is. Or is it... Oh, man. What's it under? Oh, sorry. Math. I said you go to math. Maybe go to probability. Sadly, you used slide rules back in the day. Stop, dude. You did not. Oh. It's on here somewhere. I just can't remember it. I think it's like inverse PDF is what it is. Linreg, no. Or it's like inverse norm. One sec. Now I'm upset. I want to know what that is. One sec. TI-84 area z-score. Yeah, how do you do it again? Second. It's under distribution. Oh, okay. Duh. That makes sense because it is a distribution. Sorry. You go to second distribution here. Okay, here it is. This is it. And then you go to it's normal this. Oh, here it goes. And you say what the lower is. So negative infinity is like the lowest something. Well, actually, no, here it was. Our lowest here was 25. Our upper was 31. Our mean, that's what mu is here. That's 28. Standard deviation was 3. And it gives you the same answer. You see how you get like 0.68? Yeah. So that's another easy way to do this without even having to go through all those steps. But depending whether your teacher allows you to use a calculator or not, it's good to know the table way anyways. Yeah. Cool. Okay. Awesome. I hope that helped. Evoli, feel free to like send me other stuff while I help students, but was that useful?
Yeah, thank you.
You're very welcome. Nice. Popoile says, yo, my friend submitted a question. Look at the username, though. I will. Maria, if you're still here, what did Maria say? Thank you. Physics isn't that difficult. We're doing the big 5. Nice. The kinematics equations, those are great ones to know. For sure. I'm cooked to a crisp without you. I hope you're not actually cooked to a crisp. Okay, let's see. I did see some screenshots get submitted. Odin has one from before. Turtle Jeff. Jesus Christ, what is this? MOSFETs? Who's giving me MOSFETs to solve? That's some heavy EE, dude. Yeah, look what I'm getting in my question box right now. This I'm pretty sure I can do. I think this is probably intro chemistry. This is a little painful. Yeah, P-channel MOSFETs. This is a lot of equations. It's electrical engineering. Shows an example of how to compute sample standard deviation with 100 random numbers. That would take a while, Jeff. I don't want to do that. What? You want me to do it by hand? All right, let me pull this image in. This looks promising from some other student. Okay, let's see what we got. Sure, why not? Anything to avoid physics. What's wrong with chem? What's wrong with chem? I like chem. I think chem's great. Okay, precipitation of an insoluble salt is used for gravimetric analysis using mass to analyze composition. Cool. Yeah, gravimetric. So grav means gravity, right? So using the force of gravity, which is the weight of something, to analyze what's there. Okay, so they take lead 2 nitrate, that's this thing, the PbNO32, with excess potassium iodide, that's Ki, which causes a precipitate, PPT. Usually we call this just like a solid. I don't know why they're putting PPT on it. Chem is even less pure than physics, I know. Then the balance equation is as follows. Write the net ionic equation for the reaction as shown above. Okay, cool. I like this. So when writing net ionic equations, what you want to do is you want to analyze so first you want to write out what the general full chemical equation is. And then you need to go through and talk about like what things when added to water, like when they're aqueous, what things are going to ionize. And ionize means they're going to break up into constituent ion parts. What the fuck you mean by PP? I think they mean precipitate. It's kind of a weird thing to do there. Okay. So potassium iodide, that is aqueous, so that's going to break up. Okay, well, they didn't give us any room here to solve this, dude. What? Okay, I'm gonna do it. Whatever. One sec. Let me copy the question, like, over here. What's up, Roman? Good to see you. Starting classes in October. Dub, dude. What classes are you starting? Okay, so potassium iodide. Potassium has an ionic charge of +1. Iodide has an ionic charge of -1. If you're curious what the charges are, you can always go to a periodic table. And here, let me just like Oh, can I just open? Do I want to open this full screen? I don't know. This is kind of whatever. Yeah, cool. Whatever. Periodic table. I'm quite fat now, though, because of my age. It's okay to be fat. I mean, you can still get your health together if you want. Bachelor's of Science in AI. Oh, that's cool. They've already started doing those. You can now get a degree in AI. Wow. That's cool. Okay, ionic charge. This is +1. This is +2. This is like Mystery Land.
Surprise, motherfucker.
Of like +2 or +3. We don't actually really know. There's so many exceptions. This is +3. This is plus or -4. Then you have -3, -2, -1. So potassium, which is here, that's a +1. So I'm going to say, cool. I have 2K +1s. We just say plus there. And then I also have 2 iodides. Iodides is in the -1 corner, so I'm going to say 2 iodide minuses. Okay. Now we look at lead nitrate. Okay. They told me it was lead 2. That tells me, so even though lead, which is PB, which is, where is PB? Where'd you go, PB? I see Sibley, SB, antimony. But where the fuck did PB go? Sorry, what? Where's lead? Oh, here it is. Lead. Yeah. Okay, so this is, we don't actually really know what this charge is, but when they say lead 2, that tells me the charge of it is a +2. So I'm going to say, cool, this is PB2+. And then plus, notice how there's an extra like subscript here. That means there's 2 nitrates. So I'm going to say 2 nitrates. And if I needed 2 nitrates to balance a +2 PB, that tells me that each nitrate is a -1 charge. Right? Because 2 minuses with a 2+ gets me a neutral thing. You can also look this up under the polyatomic ions sheet. Okay, and then we have plus this, but this is a solid. Solids don't ionize. They stay together. So this is just going to be PbI2. We're just going to leave this how it is. And then you have potassium nitrate. Same deal here. Potassium is a +1, and you have 2 of them, so you have 2K plus 2 nitrates, which again are a -1 charge, because this thing is -1, and then this thing is +1. Popoli says, I'm going to add 1 element to the periodic table. No way they forget the most important element. Which one is it? Which one are you talking about? There are some wacky periodic tables. Have you guys seen the wacky periodic tables? Or is it wacky, or like alternative periodic tables? They're actually quite hilarious, dude. Yeah, look at this thing. Like, what? What is this? Or like this. This is also a periodic table, apparently. Or this, the circular periodic table? Dude, what? Yeah. Or, oh, this is it. This is funny. This is it weighted by which one's the most abundant, I think. Yeah. Anyways, we're going to use the standard periodic table, because that's what you learn in class. The Henry Moosley table. I want what they smoke. Yeah, seriously, dude. Did you know, who's that guy, that actor who played in Iron Man? Oh, man, what's his name? Black guy. I forget his name. Fuck. Terrence Howard. He has his own periodic table as well. His is quite funny. But, okay. Now I want to figure out the net ionic equation. This is the same thing as math. All you're going to do is look at this equation that you've written. This is the full ionic equation. Okay? Oh, I fucked this up. Oh, no. Oh, no. Okay, whatever. I just got to delete all this. One sec. Take this down. They smoke cigars, the good vintage ones. I like cigars. Cigars are nice. To get the net ionic equation, you just cancel what things on the left side of the equal sign, cancel out things on the right side. So I notice here I have a 2K+. I also have a 2K+ here. These are going to go away. I also have 2 nitrates. So what I'm left with is this and this. So now my net ionic equation is 2I plus PB2 plus gets you PBI2. And then you're supposed to write, I think, solid here. And then I think you write these are also aqueous. If your teacher gets mad at, like, the states. Yeah. The cigar Bilbo that Gandalf smoked. Yeah. So there you go. That's it. That's the net ionic equation. The other things that got canceled out, if your teacher ever asks, these are called spectator ions. Because they don't really participate in the precipitation reaction. They just kind of like chill. Like they're there at the beginning, they're there at the end. Did they really do anything? No. So they're spectators. Okay, cool. So yeah, that's how to write a net ionic reaction. In general, if you want to like cheat and like just get ahead, usually the net ionic reaction is going to be whatever the solid thing is and whatever made the solid thing, just adding up to it. So in this case, PbI2 got put together because, again, you had two I minuses and you had a Pb2 plus. Bingo. That's all you really had to do. This is chemistry, Sweeto. We're just helping students out with random math and science questions that they have. So if you want to submit one for us to go over on the stream here, we'll do it. Last time you did chemistry was in 9th grade. Last time I did chemistry was, I don't know, about 30 seconds ago. Last time you looked at chemistry, Roman, was right now. Okay. Let's see what this says. The particulate diagram is incomplete. Draw in the particles needed to accurately represent the major ionic species in the remaining solution after the reaction has been completed. Well, no, I see stuff, right? We got potassium. We got iodide. Oh, we don't have lead. Well, also, like, we have to, like, kind of say that, right? This thing here is PbI2. And also, we don't know that all of the Pb2 plus and all of the I2... Sorry, all of the I1 plus is going to react. So, technically, I think you still need to do this. You do still have some Pb2 plus hanging around. It's just a lot of it will hopefully... Oh, I guess... Yeah, excess potassium iodide. No, that makes sense. So, wait, all of the Pb should then precipitate. Because... you have excess amounts of this, which means all of this should get used up. I had a great chemistry with an ex-lover. What? What type of bonding was it? Was it covalent? Was it ionic? Was it hydrogen? London dispersion? What type of bonding did you have with your ex-lover? Okay. Let's see. There's a lot of stuff going on here. I'm not sure I'm going to do all these questions. Unless if you're in my chat right now and this is your question, if you want to let me know exactly which one is like bothering you the most, I'm happy to like do that one. Otherwise, I'm just going to pick a random one. So, let me know if you're in my chat and this was your question you submitted me. Let me know which one you want me to go over. I'm not going to do all of them because that's a lot. It would take me like... What's up, Odin? What's good? Ions are alive. Evolution can get pet ions. Let me think which one I want to do. Well, this is like a new reaction. I don't want to like do new reactions. Let's do this. Let's do part C. I think we should do part C. Part C, I think, is cool. Let me get the original reaction up here as well. We were quite satisfied with each other, but we had to move out of town because my truck driving work in 1996. That's right. You did tell us, Gmail user, that you were a truck driver at one point. Or you still are a truck driver? I forget. Big rigs are cool, dude. Did you drive stick or did you drive automatic? Because, dude, stick on a big rig has like, dude, the gear configuration map is nuts on that thing. Gear map, semi-truck. Automatic now, yeah. But did you ever drive stick? Yeah. bro, like, look, excuse me, look at this. This is the shifting pattern. What? Like, how the hell do you know where all the gears are? I think they have made it easier, right? Is this a little bit easier? That was the norm before, dude. Jesus. I guess this looks a little easier to me. This looks like a standard, like 6-speed, but they've, I guess, yeah, high, low, high, low, high, low. Yeah. It sucks now? Aw. Yeah. This to me is a nightmare. I don't know how you would memorize this. This looks like a web pattern. Okay. All right, let's get our reaction here. Manual transmissions, how old-fashioned? I asked my UCLA class who can drive stick. Only one person raised their hand. Out of 200 people in my class, only one of them raised their hand. Okay. So they had lead nitrate, which they reacted with excess potassium iodide. What mass of lead iodide would they expect to produce? This is cool. So this isn't a limiting reactants question because they already told us which one is in excess. Sometimes they'll give you two amounts. Like, they'll give you, like, the amount of this reactant and the amount of this reactant, and you have to figure out which one runs out first. That's a limiting reactants question, which are very popular. I've done them before, but we're not going to do it on the stream. So this is basically a stoichiometry question. So we say mass of lead iodide. So I'm going to say how much grams of PbI2 is equal to what you start with, which is 2 grams of lead 2 nitrate. Okay, so I'm going to say PbNO3 2. Okay. Whenever you have two different species, right? Two different things, right? This is lead iodide. This is lead nitrate. The first thing you always want to do is convert to moles. Because once you have things in moles, you can do what's called like the mole ratios to convert between like species. So I'm going to first turn my 2 grams of lead nitrate into moles of lead nitrate. And what I know from here, the molar mass, is that 331.22 grams of lead nitrate is equal to 1 mole of lead nitrate. I teach at UCLA. I did. I taught in the spring. I taught in the summer. I don't think I'm teaching this fall. UCLA is going through a lot of bad shit with like funding. I might teach in the winter or next year. But yeah, I was a lecturer. They call me like lecturer emeritus or whatever. But I basically was a professor for physics classes over there. Okay, so then one mole of lead nitrate, so 1 mole of this, is equal to 1 mole of PbI2. That's actually really nice. So here, I can actually just... They made our job super easy today. Fluids. Not exactly. This is just chemistry. If you want to ask a fluids question, you can. I can try to solve it for you. Okay, so 1 mole of this is equal to 1 mole of this. That's really nice. It's just 1 to 1. And so here's a cool thing you should notice with stoichiometry. So grams of PbNO3 canceled out with grams of PbNO3. And then moles of PbNO3 cancels out with moles of PbNO3. So now we're just left with moles of PbI2. Awesome. But I'm trying to get to grams of PbI2, right? So my final step here is to use the molar mass of PbI2, which they tell me. This question is actually really generous. Usually you have to go look this shit up, or you got to go add it up. It sucks. So they tell us that we have 461 grams of PbI2 in 1 mole of PbI2. If you're ever confused, like which one goes on top, which one goes on bottom, because you'll notice I almost messed up there. You always want to make sure that this thing cancels out with the thing before. So this cancels out with this. And now we're just left with grams of PbI2, which is sweet. Because all I got to do is now pull out my calculator. and we're just going to multiply everything on the top and then divide it by multiplying everything on the bottom. So pull up the calc. So we have 2 times 1 times 1 times 461. That's on the top. We're going to do 331.22 times 1 times 1. It's the same shit. Okay. And then we just do top divided by bottom. So top divided by bottom. And that's going to give me 2.78 grams. So we would expect to produce 2.78 grams of precipitate. If you don't believe me, we can always throw this in the ChatGPT real quick. So let's just do that. Again, I'm all for using ChatGPT to check answers. Super cool. I think it's very useful. Here, solve part C. It'll crank away. Get rid of the calculator. There we go. Nice. Blah, 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 blah. They got 2.8. Is that what I got? Yeah, 2.78. 2.8. Yeah, same answer. Nice. Good. Awesome. We did it. Sweet. Good job on the chem. I like chem. It's one of my other favorite sciences to teach. Chem, I mean physics is my favorite science to teach because I do it the most. Chem is probably a close second. And then I don't know. I mean stats isn't really a science, but I don't like teaching biology. I think biology is just a bunch of memorization. Math is my secret favorite. Yeah, if you had to ask, what subjects do I like to teach the most? I mean, calculus, probably. I really like teaching calculus. I think calculus is really cool. What about solid-state chemistry? Ooh, like NPN transistors, barriers, and stuff. Or was it crystallography? Or quasi-crystals? That's all kind of like solid-state, right? I did take a solid-state engineering class, it's not engineering, sorry, solid-state physics class in my undergrad, and I understood absolutely nothing. It was really difficult for me, honestly. I had to get my friends to kind of carry me through that class. What they call Briand zones and stuff. All right, someone submitted this with ceramic method, thin film analysis. Yeah, exactly. All that stuff it's cool. It's very specialized, but not my cup of tea. I'm not super into that stuff. I'm also not super into this either. This is hardcore. Who submitted this to my channel? This is pretty hardcore electrical engineering. Because this is MOSFETs. This is so with circuits. I'm cool doing I can do mesh analysis. I can do KVL, KCL, resistors, caps, whatever. When we start getting into transistors, things get a little bit more weird. I have done this, but yeah, look, bro, we just start what? What the fuck is lambda? Lambda is inverse volts, and then MAN squared. I don't know what half the shit is. Yeah, okay. This is a great example of I appreciate this question, but I can't answer it because this is pretty advanced electrical engineering. I know you electrical engineers probably in my crowd will be like, oh, it's basic, but I just don't know the equations for these. I know RL is usually this is the load. I think I understand this. This is there's a load being connected to, this is an amplifier, I want to say. Yeah, it's an amplifier. So an amplifier takes a voltage or takes a signal is what it does, sorry. It takes a signal, which I believe comes in through here, Or maybe it's... I forget where the... No. Signal, I think, comes in through here. And then it gets amplified through, like, a load. This is how, like, speakers work, by the way. These are cool. This is... What's up, Daimo? Daimo, is this your question? Did you ask me this one? This is how, like, speakers work. Speakers take, you know, waves of a song, and then they amplify those through an amplifier, and then that signal gets sent to a speaker. The speaker is seen as, like, the load at which the signal runs through. Yeah, that's where this comes from. It's cool. Sib says, physics is so hard. It must have taken a lot of work to love physics. Yeah, the signal's on the right. Yeah, and the amplifier from top, higher voltage. Yeah, exactly. Right, and then this is the load. This is, like, the speaker it goes through. The issue is that, like, solving... So here, I'll have ChatGPT solve this one just so you can, like, see how it's solved. There's a lot of really specific equations that I don't have time to look up because I don't do this on the regular. But, I mean, let's just see it. I'm curious. This is, again, another way that you can use AI to learn. I'm just going to see how it does it, and I want to see what the solution is. And then I can kind of, like, reverse engineer it, I guess. But yeah, MOSFETs are pretty common in electrical engineering. But I never took any formal electrical engineering classes in my whole, like, PhD progression. Yeah. You don't think you can solve it? I think it can. I'm pretty sure it can. We'll see. It's gotten damn fucking good at reading diagrams. I agree, back in, like, ChatGPT, like, 3.5 or even, like, 4.0, I don't think it could do this. 5 can. I've seen it do some pretty crazy stuff with, like, circuit analysis. I know that because when I was teaching E&M and, like, I was teaching the circuits version at UCLA, when I designed my circuits, it was very difficult for me to design circuits that ChatGPT could not instantly analyze and figure it out for the exams that I wrote, because it was an online class, so all the kids I knew were going to use ChatGPT at some point. But you had to be really finicky to try to trick ChatGPT. It's hard. Yeah. Well, let's see. I think it already did. So yeah, let's look at this, right? So it thought for a minute, and it says, yeah, this is a P MOSFET, grounded by CS. Output is taken as drain. Output is taken at the drain. Oh, so it thinks the output's coming here at RD, not RL. Gate is the input. Sure. So I think that's this on the left, coming into the right. Right, that's the input. Treat them as shorts, mid-band. This is where, like, yeah, this is terminology I don't know. The drain is connected to the ground, drain node coupled, small signal device. So the gain is V over VI, which is, this is called, I think, the grand mean. RDRORL, but look at this. It's so specific. Yeah. Yeah, no, this is, yeah. Nope. But it's cool. I think this answer is probably correct, honestly. It's just, this is very specialized electrical engineering stuff that I don't know, let alone do I don't teach it. So, but cool. I appreciate all sorts of questions, though. It's fun to, like, see what people are working on. Yeah, it's good. Daimo, dude, it's fucking good. If you use the paid version, at least. Okay, let's see. Do we have any other questions for today? Nick, did you want to go over anything? Otherwise, Sib, I'll go over your question. I kind of liked yours, Sib. It was this one, right? Let C be oriented curve parameterized by this. Calculate the contour integral. 2x y dx plus this. Da, 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 da. And I think what we did during yesterday's stream is we showed at least that the vector field we're looking at was conservative, right? Yes. Okay, cool. I want to know kind of where this comes from. I think we did come into this, right? We said, so if you have a vector field F, which the vector field is the derivative, is the gradient of some function F, which I believe this is the potential. I think this is here. This is the potential. So in what is it? In E&M, I think what we say is that F, which is a field, is an electric field, is equal to the grad of the potential. I think this is what we say here. The anadelta? Is that what you call the nabla? You call it anadelta? Because it's an upside down delta? Right. And then I'm trying to think how this works. Okay, so here's the cool thing. I think from Maxwell's equations, correct me if I'm wrong, I think E dot dl is equal to the change in potential, right? We say like delta V, or we could say here, so from like position 1 to position 2, it's equal to like V2 minus V1. I think this is from Maxwell's equations, right? Yeah. E dot dl is equal to, yeah. Oh, that's ddt. No. What ddt? Oh, yeah, it's the change in potential of the change in time. You got your degree recently? Oh, congrats, dude. This was so difficult. Yeah, E&M is kind of a bitch sometimes, for sure. E dot ds is change in magnetic flux? No. I wonder where this comes from. So sorry, like, okay, this is it. This is what I want. Dude, yeah, here's our boy flipping physics. What's up, Jonathan? Yes. Here we go. Change in potential is equal to the integral of E dot dr. Right? Okay. And so, if E is defined as nabla V, so, right? So, yeah, this is, sorry, it's E dot dr, right? Yeah, it's what I have written here. Let's just keep it as dl. I don't care. Never understand how to practically use it. Yeah, so this is cool because what Sibley's giving us right here, Dymo, is this is a vector calculus question. So a multivariable calculus question. However, it has a lot of parallels to what she learned in my electrodynamics class that I taught at UCLA. She took that class with me, and she's seen stuff like this before. And I like to like kind of show how it's the same, you know? Yeah. So when we do this, yeah. This is also why, for instance, E is equal to grad V. Okay, so if you do the integral, right, from 1 to 2 of grad V dot dl, you should get V2 minus V1. And again, correct me if I'm wrong, I think this is parallel to what the fundamental theorem of calculus is, which tells me, right, if I have ddx from 1 to 2 of, let's say, f of x dx, I believe this ends up being just, f2 minus f1, right? Where it's like f of 2 minus f of 1. This is the fundamental theorem of calculus. Yeah. And so this derivative here is very similar to this. Okay, like if I move this thing inside, right? Nabla V is just the vector form of dv dx x hat plus dv dy y hat plus dv dz z hat. It's just like, it's a multivariable derivative. So this is like effectively grad v. Cool. So then all you have to do is you just have to integrate what's in here, right? So if you integrate this, then that'll get you what v is. Okay, cool. And I think you're only allowed to do this if, again, it's conservative. And we proved it was conservative by doing these tests. You have to do these tests on your whatever the field is. So yeah, so no, I think this is, yeah, this isn't little f, sorry, this is big F. It's just big F. But then I know that this whole thing here, right, is equal to 2xy dx plus x squared plus e to the y sine z. That's in the x hat direction. That's in the y hat direction. Plus e to the y cosine z. Z hat. And then this is dotted with DL, effectively, but this is like a three-dimensional DL. Right? So all you have to do is integrate this to figure out what f is, and then you just figure out what your endpoints are. So if I integrate this with respect to x, that's going to get me x squared y. So here. So we're going to say that f is now equal to x squared y plus the integral of this with respect to y, which is going to be so this is in the x hat component. Sorry, are you also this is still a vector though. So you have to keep the components the same. So this is x squared y. The integral of this would be x squared y plus the integral of this. Integral of e to y is just e to the y. So that's e to the y sine z. Vectors! Yeah, what's up, Zach? Good to see you, dude. I don't know if I asked you this, Zach, earlier, but I was kind of reviewing. First of all, I forget what this theorem is, where if you have a conservative vector field, and then you have the integral of like this dot dl, it's equal to like the potential at one minus the potential of the other. Good. The fundamental theorem of line integrals. Is it safe to say that's similar to the fundamental theorem of calculus? Is it like an analog? Use AI mode. What? Yeah. What? I'm not interested right now. What? It is. Okay. Cool. Nice. Oh, I love Paul. Let's see Paul's math. We love Paul. Paul's great. Yes, this is what I was thinking of. Okay. Oh, very cool. So they are connected. It's a variation on it. Very cool. I think that's the coolest thing about math sometimes is you start to see the parallels and the trends keep repeating, and then it starts to like click. And you're like, awesome. Okay. Got a riff on the FTC. Yeah. Fundamental theorem of calculus. Yeah. We learned this in calculus, and I don't think people appreciate it for what it is. You're just like, oh yeah, whatever. I plug in the bounds and like we're fine. But it does come in handy here. Okay, very cool. Now, it doesn't talk anything about it having to be... Okay, no. Here it is. Sorry. It does have to be conservative. Okay, so it does have... The path has to be closed, simple, all that fun stuff. Okay, cool. All right. So yeah, we proved it was conservative. I think it... That's all Calculus 3 is. It's just the fundamental theorem of calculus. Okay. Cool. Yeah, we proved it was conservative doing this stuff. We showed that, I think, whatever these, like, determinant cross product derivative things are 0. Okay. So then, all that's left to do is to do this. Can you summarize what you just did? Yeah. Everything builds on each other, it does. Have you shown it? I forget, Zach. Which one is it? Okay, so Odin root. Here's what we did. So they wanted us to calculate this, and it's for going from like t equals something to t equals something. I think they give us a parameterization on it too. Let me find the parameterization. Yeah. So x, y, and z are parameterized by t, and t goes from 0 to pi. So what I show here is that this thing is the same as div dot f. Div dot s. Sorry, it's div dot f dl. Is that what we're saying? Oh, sorry, it's not div, it's the gradient. Sorry, it's the gradient. I don't know why I kept running div. It's not div.f. Sorry, it's the gradient of FDL. Yeah. Gradient of FDL is equal to, we say, like, f of 2 minus f of 1. If my curve is going from, like, some position 1 to some position 2. Right, and then in order for it to be conservative, okay, they say big F is the vector field. Okay, cool. Okay. I think I see what's happening here. Right. So really what we had here, to start with, let's just start, is we had the integral from 1 to 2 of some big F dot dl, okay? And then we recognize that, like, okay, this may be a vector field, okay? And it's a vector field such that big F is equal to nabla F. And this is called a potential. This is called a vector field. And sorry, I should put things on these. Okay. Nabla F will instantly turn... So F being a potential, that's a scalar, which means it doesn't have direction. But when you take the nabla of it, nabla F is equal to df dx x hat, or here we can do this as like a vector. I can show it. It is a vector. Df dy comma df dz, such that this is a vector, again, x component, y component, z component. In order to show, but in order for this thing to hold true, I need to prove that F is a conservative vector field. I'm not exactly sure why I need to do that, but it's one of the rules. So F must be conservative, not liberal. Don't bring politics into math. And in order for it to be conservative, it's like dfx dy minus dfy dx must be equal to 0. dfy dz minus dfz dy must be equal to 0. And then dfx dz minus dfz dx must be equal to 0. if this holds true, the thing is continuous, it doesn't divide by 0, it doesn't break, then you're okay saying that this is a conservative field. And if it's a conservative field, you can now claim that this thing is really the gradient of some potential. And if you figure out what the potential is, then the line integral of the gradient of the potential from point 1 to point 2 is just the value of the potential at 2 minus the value of the potential at 1. i.e. curl of f is equal to 0. Okay, very cool. Oh, okay. So curl f is equal to 0. Sorry, I forgot the cross product. That's very cool, Zach. Okay, and these are cross products. Yes. Because look, if you want to see what the curl of f is, right? That would be this. That would be ddx, ddy, ddz. And then it would be fx, fy, fz. These subscripts indicate, like, what component of f. And then this is, like, I hat, j hat, k hat. Very cool, Zach. Yeah, because if you do the cross product of this, using what we know our rule for cross products is, right? That's this minus this, which that's the dz dy minus dy dz. Yeah, right here. Fuck, that's so cool. My least favorite mnemonic. Wait, what's the mnemonic? Is there a mnemonic for cross product? Oh, the determinant thing. Yeah. There's also the ones where they expand it out and then you do this. I don't like that. I think it's goofy. I forget what that method's called, but it's a goofy ass method. Okay. So, now all I have to do is figure out what f is. And so I know that grad f, right, this is equal to what I have. So I know it's equal to 2xy, comma, x squared plus e to the y sine z, comma, e to the y cosine z. Right? So that means df dx is equal to this. So if df dx is equal to 2xy, all you got to do is just move this over. Integrate. And so now you just integrate this with respect to x. So you get that fx is equal to 2x squared y over 2, which is just equal to x squared y. And then we're going to do it for the other ones, which is what I was doing here. Let's see if I did it, sorry. So x squared y plus e to the y sine z, and then comma, the integral of this with respect to z would be e to the y sine z. And this, sorry, this is not big F, this is little f. This is the potential. Very cool. So, this is a very cool question, Sib. I like this one. So now all I have to do is just do f of 2 minus f of 1, which is f when t is equal to pi minus f when t is equal to 0. But then t is a parameterization, okay? Whereby x is equal to t squared, y is equal to t, z is equal to 2t. So this is f of, so t is pi, so that's going to be pi squared, comma, pi, comma, 2 pi, minus f of 0, comma, 0, comma, 0. And so this is what we had for f, right? So let's figure out what that is. And sorry, f is not a vector. F is no longer a vector. I don't think it is. Or no. Sorry, wait one sec. Oh wait, I think I fucked this up. Yeah, f F is a scalar. Okay, so this is not right. Sorry. Okay, one sec. We are close. We are close. I messed this up. I remember how you have to do this now. Okay. All right, here's what I say. I know that df dx is equal to 2xy, right? Plus... Or no, let's just do this. I'm just going to do this, right? So that means f is equal to x squared y plus a function, let's say a function g, that depends on y and z only, right? I know this part of the function exists, right? So if I do df dx of this whole thing, this only depends on y and z. The derivative of this is 0 with respect to x, so only this would become 2xy. Okay. I think I got this. Sorry, we got to move all this down because we're not there yet. Okay, I know that df dy is equal to x squared plus e to the y. Do you see that, Sib? Yeah, I was wrong earlier when I was just like saying component. That doesn't work. F is a scalar, which means it doesn't have components. It's just gonna be a big expression that when I take partials with respect to x, I only get this. And that would, exactly, partial means a derivative where I only look at one variable. In this case, I'm only looking at x, right? So if g is a function of y and z, the derivative of this, right, ddx of this would go to 0. And then ddx of this would get me 2xy. Okay. So I know df dy is equal to this. Okay, so let's integrate this, I think, with respect to y. So that means f is equal to x squared y, which I already knew, right? Plus the integral of this with respect to y is e to the y sine z. And then it's plus a function h that's only a function of z. Okay, this is pretty cool. Because this already matches with this. What level math is this? This is vector calculus. Or multivariable calculus. Okay, and then gyz is equal to e to the y sine z plus something else that's a function of z. I might be doing this wrong. Engineering, yeah. And then wait, okay, so then df, this is, yeah, like second year calculus. It's diff f with respect to y that you just found. I think this thing can only be a function of, well, let's see. Then compare it to the second component. Anish? Okay, yeah, let me check that. So df dz would be equal to, needs to be equal to, sorry, df dz needs to equal just e to the y cosine z. Plus some function that's just a function of x. Right? Oh, plus, okay, wait. Plus, I'm not going to say f, sorry. Let me say like some function of x. How to find g initial conditions? No, not quite. I think you use the next derivative to kind of find out what g is here. So, for instance, if I take df dz is equal to this, then that tells me that f is equal to e to the y sine of z plus something else. Okay, actually, I think I figured it out. Sorry. This tells me, when I take the integral with respect to y, that it's equal to this plus some function, let's say h, that's a function of x and z. And then this tells me it's equal to this plus some function, let's say I, that's dependent on x and y. So, and I think we just compare it all, is what we do. Like, what makes this all true? Okay, well, in this case, right, I'm going in the right direction, but I'm doing extra work. Yeah, I'm sure I am. I think what I'm doing is I'm seeing what's in common, right? You see, like, I have this. That's cool. And then I also have this, and I also have this. So I think I'm cool with just this. I think f is just equal, like, f is just equal to this. F just equals x squared y plus e to the y sine z. Because in this case, this thing is x squared y. In this case, this thing is 0. And in this case, this thing is e to the y sine z. Yeah, you're looking at, like, what's common amongst all of them. And then you want, like, the superposition of all those things. I am doing extra work, for sure. I think I could have honestly stopped here and been done. But you can also do this. Just to verify, right? Because now I look at this, right? With respect to z, I get just my e to the y cosine z, right? Because I'm just taking the derivative of this. This doesn't have z in it. With respect to y, I get my x squared, which is what I wanted, plus my e to the y sine z. Yeah. Let's see. Anch says, let me see, because Anch probably has a smarter way to do it. He says diff of the first f you found is similar to the second component, so the comparison will work. Nice. Nice. What's up, Onage? I'm doing vector calculus. This is multivariable calculus. Feel free to submit your own question if you want to go over it. I'm just helping a student right now with theirs. You are right, Anch. Yeah, if I just compared this to this, then I already know that g of yz is equal to this. And then we don't have to go any further. Yes, Nick, I'll do yours next. Okay, cool. So this is my function now, right? So now, Sib, we're doing f2 minus f1. You submitted more Calc 3. We love Calc 3. You do have a question? Oh, what's your question? I see one from Rust Coder, but this is really blurry, dude. What? How am I supposed to read this? The aspect ratio on this is terrible. This is Odin's. I like that. That's a good one. King Croc. Ooh, this is cool. Is this Newtonian fluids? Thank you, King Croc. That's a cool one. Okay. Yeah, just use that website below, and I'll see if I have time, and I'll try to get to them. I am considering streaming more, maybe on Fridays and on Sundays, or maybe just Sundays, I think. It's helpful. This kind of stuff kind of hurts my head. Yeah. The partial derivative means that you're only looking at the variation of something in a certain direction. Okay, so let's just do this real quick, because we're almost done. So f of this at x is equal to pi squared. So that's going to become pi to the 4th, right? Because x squared is pi squared squared. And then that's times pi. Plus e to the y. Y is pi. And then sine of z. Sine of 2 pi. Sine of 2 pi is 0. Love that. That goes away. Okay. So we're just left with pi to the 5th for this. And then f of 0, 0, 0. Okay, well, this goes to 0. Sine of 0 is 0. So this is minus 0. So I think the final answer is pi to the 5th. I think it is. Sibley is a student. I'm a professor. Calc 3, my beloved, right? Okay, let's see. Was the answer pi to the 5th? Oh, look at that. Look at that. The answer was pi to the 5th. Hell yeah. Nice. Good job, everybody.
Let's see Paul Howard.
Wow, I thought it was cool. I teach physics, Anch. Physics. Yay! I'm glad we did that one, Sib. If you come by the stream again, which I know you do, you're great at coming by the stream. I'll do the part B one later. That one was pretty cool. Gordon Freeman. Oh, welcome, Mr. Freeman. Wake up and smell the ashes. I just took my Diffie-Q exam and I forgot the quadratic formula. Uh-oh. I do have a PhD in physics. If you want to go read my PhD, here's my stuff. I'll send it to you guys in my chat. You guys can go have fun. I say, go have fun. There's my thesis. I did plasma physics. I don't do any plasma physics now. I teach mainly like undergraduate physics. Okay, Nick, coming up. Let's do some of yours, and then I'm gonna hit Odin Root's question, and then anybody else. Anybody else in the chat, if you have questions you want me to go through, and you're cool, maybe waiting like 10, 15 minutes, I'll do it on the stream here. So just go to that website, submit a question. Nick, what's up? Where's Nick? I gotta ping you, Nick. Oh, you probably gotta rejoin. Okay, that's fine.
Can you hear me?
I can hear you now. All right, which one you want to go through? Which ones? We did all the filing the motions of appeals and shit, I'm pretty sure. I mean, I guess we didn't do this one. Here, I'll throw this one up. Explain to me bosonization, dude, what? You have a Houston area code? Yeah, I grew up in Texas. I grew up in Houston. I was born in Chapel Hill. I've lived in New York, Vermont, Atlanta, Georgia. But I would say I spent my formative years in Houston, Texas. And then I've been in LA here for the last 15 years, so I don't know. I feel like I'm pretty much an LA person. I have no clue.
Which one is better?
Which one's better? The weather's much better in LA. Although I will say I kind of miss the people in Texas. Texas people are real. You deal with a lot of fake people in LA. Okay. Let's see this. I don't think we did this one. Yeah, so do you think you can do this one?
This one was weird in the beginning, and then I had to use my my pea brain.
You used your pea brain. Good. I'm glad you used your brain. Okay. So it says I always like to write out what it is, right? So 72 is equal to 2/5 of the capacity, right? And then they're asking you for the capacity, right? The number of people you can fit in there. So instead of capacity there, let's just say this is X. How do you solve for X?
I think there's 2 ways I found out that you can answer this.
Which way do you think?
You could do 5 divided by 2 times 72, or you could do 2/5 divided by 72. Or is it the other way around?
No, you can't do 2/2. No. So the only way to get rid of this, right, is to multiply by its inverse. So you got to multiply both sides by 5/2. Okay. So then you're just left with this, which this is cool because you can cancel this with this to get you 36, right? And then 5 times 36, that's 150 plus 30, so that's equal to 180. So answer C. Not too bad.
I think I tried this. I don't know if I forgot already if that worked.
You could divide both sides by 2/5. Yeah, that's true. You could have divided 72 by 2/5.
Yeah.
Yeah.
Yeah, that's what I did. Yeah.
Yeah. So if you're going off the basic let me just get rid of this by dividing by it, but then that's just dividing by a fraction, which from keep, change, flip, that's the same thing as 72 times the flip, which is 5/2, which is the same thing as this.
Oh.
Yeah, it's the same thing. Yeah.
Cool.
Okay. Well, and then all these. Is this just basic arithmetic? I'm really curious about these questions.
This is college. Yeah. Yeah.
Red Roach is I just came back and you switched from vector calc to multiplying 2 numbers. Yes, let me explain. Sorry to the people on YouTube who are probably confused at the continuity. I help all I help a very wide spectrum of students. So I have everything from middle school students who are just learning how to add and subtract and divide numbers to, you know, high school students that are probably taking their first chemistry or first physics course, to people taking upper division math courses, like, you know, DiffyQ, vector calc in college. So it's a very wide spectrum, but at the current point in time, my stream isn't super slammed with people that I can cover all of it. Eventually, like, what will happen when this gets big enough is I'm gonna have to designate certain days to certain, like, subjects or areas. Like, Wednesdays college, Thursdays high school, Fridays middle school.
That's
because there is a disconnect. I mean, the audience watches and they're like, wait, what the fuck? Like, we were just doing vector calc and now we're adding two numbers together. And then the people who need help with adding two numbers together are absolutely fucking lost at seeing vector calc. They're just like, oh god, what is this?
Oh no!
Like,
oh no! No!
Okay, but this isn't
perfect.
I love that monkey. Okay. Like this, for instance, adding three numbers. This is a little bit easier than doing a contour integral, for sure.
Guys, this is a college math. Trust.
Yeah. Okay. Do you get a calculator? So, another bit of background here. Nick is a longtime student of our community. Actual Education. We're actually a nonprofit. And he's studying for a government exam to become a court officer. And so this is part of the exam, which I always find it interesting to look at these government exams because it's so funny what they test you on. Like, here, this is mechanical, dude.
Especially when they give you the answer that's supposed to be right, but it's wrong.
Yeah. Our tax dollars at work, dude. Seriously. Do you get a calculator on this exam? I'm confused.
I don't know.
Like, do you have to do this by hand? Like, this kind of sucks. You gotta do this by hand.
Yeah.
Okay. 5179 plus 29.39 plus 8.98. There's just so many nines. I don't like these. You can add all these together. So 51 and 29, what's that?
80.
Yeah, 80. And then we add 8, right? So I know I have 88 at least. And then I can add these up. Just add the 10s and the 1s digit. Exactly, right. Yeah, this is 7. Oh, no, that's another way to do it, Zach. I like that. Yeah, multiple choice for the win. Oh, okay, cool. So, yeah. Sib says, I really like the name Actual Education because awesome cause. Yeah, also because, I'm trying to actually teach things. I don't know, I feel like, Zach, we were talking about this, right, during your stream, how, some math, I need to watch the rest of that video about why, what was it? The order of operations is morally wrong. I have it saved. I'm going to watch it. But yeah, some ways that like math is taught or like education is taught isn't really education. It's, hey, follow this path exactly. Oh, wow. Zach, we might have something there, dude. What if we do something with exactly Zach? I don't know, it's too much. But yeah, it doesn't encourage you to actually learn things on your own. You're just memorizing shit, and yeah, it's the worst. So yeah, for me, like Zach was also talking about this with, sometimes they give you these big fucking equation sheets in math and it just looks like formula vomit, and that's supposed to be education, and to me that's not education. I agree with Zach that you should learn a couple core ones and then you can derive all the other ones yourself, and you become more appreciative of the math behind it if you do the work to see how the other ones come about. Then it's cool. Then it's like, it's actual education. So yeah, I support, Zach, your idea of like doing another stream and I think this is what I do with my YouTube, with the little short videos I do. I try to just cut through the fluff. I cut to the bullshit, and I'm just like, what do you need to know in order to do these types of questions? Like, fuck all the like the weird theory shit and like whatever that like dismays students. Like, let's just get you to the point that you can get the right answer. And once that happens, you build the confidence in the student that they can do math. If they can do something correctly, even if it's a mechanical procedure that doesn't, again, appreciate what the overall logic is, I don't give a fuck. I just care that, like, the student now who was previously discouraged at math and thought math wasn't for them and they weren't a math person now sees that they can do math, and now they're more likely to continue doing math. So I think that's the great way to do it. Yeah, actual education. Exactly. Yeah, that's my... I don't know. I'm always fighting with people. Not fighting. I'm always having... discourse on my YouTube shorts because some math nerd will come up and start trashing my videos as being like mechanical or not showing the logic or not showing the beauty of it. And I'm like, bro, you realize this is like a 1 minute short with fucking memes and like sounds? I don't have time to show them the stuff, but we're just trying to keep them interested and build their self-confidence that they can do it. That's why we do it. I don't know. Some people just like lose the plot. They don't get it. I'm just like, it's okay. But I explain it to them, and then they sometimes they're like, oh, it makes sense now. I'm like, yes. Actually.
It seems like you really wanted to get that off your chest for a very long time.
I did, dude, because yeah, it was the other day. Someone was trashing one of my YouTube shorts in the comment section, and I had to respond. I was like, no, you don't get it. You're the reason kids don't keep doing math is because they get scared.
Exactly.
Okay, so 9 plus 9 is 18 plus 8, that's 26. Carry the 2. 9 plus 3 is 12. 12 plus 9 is 21. So 1. So then there's an extra 2 here. So, okay, cool. So you add this 2 to the 88, and it's going to be 90.16, which is answer choice D. Yay.
By the way, someone should clip that whole entire speech.
Yeah, yeah. I'm sure I'll make it again. Okay, I'm not gonna do all these, bro, because like you should be able to do this. It's just fucking like what, adding and subtracting numbers, please.
No, I need help, yo. I'm joking.
Red Roach says, "Could I hear your qualifications? Because I have an exciting opportunity." I mean, what do you mean? You want my LinkedIn? I'll give you my LinkedIn, dude. Here. You want my CV? Here. You can have my LinkedIn. Go add me. I need more connections. Thank you, Zach, for becoming my friend on LinkedIn. I feel like until I get to this magical, like, 500 plus, no one's going to fucking take me seriously yet. Exciting opportunity. Yeah, does it involve Bitcoin, please? But yeah, if you want, here's my LinkedIn. This should tell you, like, what I do and, like, what I have done. I even have my rave stuff in there. I have, like, my desert raves I threw. Because I like the show. I don't know. Like, I'm a multifaceted person. I'm a Renaissance man.
Gold has 5 messages.
I do. That's all these people. Dude, those messages are trash. It's people just like trying to, I don't know, get me to sign up for something. So those are my qualifications. If you want to go, Bitcoin, please, Dr. Gold. Okay. Here, let me do this one. I'll do a couple of these, and then Odin Root, I'll go through yours, and then I have a friend's birthday I'm supposed to go to right now. But I'm happy missing part of it because they want to go to some incredibly ridiculously expensive steak restaurant, which I just don't want to be there for splitting the bill. I know it's gonna be a couple hundred, and I'm currently unemployed, so I don't really want to do that. So I'm cool missing part of the birthday for you guys. Okay, out of 192 inmates, 96 are to go on a work detail, and another 32 are to report to vocational class. All the rest remain in the cell block. Okay, how many people should be left in the cell block? How do you think you do this one? These poor people in the cell block.
Poor Gore.
What? Sorry, was that English?
I forgot.
Okay, so you have 192 people total, okay? Right? And that has to equal 96 going to work detail, probably to like make license plates. 32 going to class, right? And then everybody else that's left has to go to the cell block. How do you think I figure out how many people go to the cell block?
You just subtract the 96 and the 32.
Exactly. Actually, never mind. I didn't realize you lived in LA. Where did you think I lived? Where was this exciting opportunity that I needed? Where did I need to live for this exciting opportunity? Okay. So, 192 minus 96 minus 32. Whatever. I'll just do the minus 96 first. Borrow the 9 or whatever. 12 minus 6 is 6. Oh, I gotta borrow this as well. Whatever, fuck. 18. 96. Oh, yeah, duh. 96 is half of 192. I should know that. Sorry. Okay, so subtract this. It's 96. Subtract 32. That's gonna get you 64. Zach says, it's interesting to see prison courtroom themed word problems. I didn't know these would make modern textbooks. These would not be appropriate for a modern textbook. But it's interesting to see them on actual tests. Yeah, this is a government test, yeah. I don't know, because, I don't know, the theme is kind of like dark, bro. It's like jail.
Oh.
I don't want to go to jail.
Scary.
Yeah. Okay. Alright, that one wasn't bad. Oh, dude, Zach, look at these questions, dude. You're gonna crack the fuck up, dude. These, dude. They're so funny. All right, this is the last one. Then I'm gonna do Odin's. Assume that you, as a correction officer, are responsible for seeing the right number of utensils are counted out for a meal. You need enough utensils for 620 men. First of all, that is horrifying that we have 620 people incarcerated. That's just so many people.
It's just one building.
1 fork and 1 spoon are needed for each man. Okay, so 1 fork, 1 spoon. How many cups? In addition, 1 ladle is needed for each group of 20 men. Okay, so 1 ladle.
The hell is a ladle?
You know what a ladle is? It's like for soup. Soup, dude. You know what yeah, like a ladle. Like, this is a ladle, dog. Yeah, this is a ladle. Bro, you haven't seen a ladle before?
I thought it was of course, I thought it was just a spoon.
It's for, like, probably scooping out whatever like slop they got these guys eating, unfortunately. Okay. So you need 1 fork and 1 spoon for every soldier. Sorry. I thought we were back. Yeah, I thought this was a military thing. It's not. So that's 620 forks plus 620 spoons. How many ladles do you need?
1 for 20. So
1 for every 20 men, right? So how do you figure out how many ladles you need?
Divided by 20?
Yes. Yeah, you do 620 divided by 20, which ends up equaling 31. Okay. So now you need 31 ladles. Okay. So add these together, you get 1240. 1240 plus 31 is 1271. Correct answer. Good job.
Wait, how did you get this?
What? What do you mean, how did I get that?
How did you do the forks and spoons?
So the forks, so every person needs 1 fork. So if you have 620 men, you need 620 forks, you need 620 spoons. Right?
Oh, okay, now I got it. Okay.
Got it? Yeah. Here, I'll save and give this one to you. This one's like, I guess a little hard.
I thought you were trying to find out how many forks, spoons, and ladles are used for the 620 people.
I am. And there's 620 forks. There's 620 spoons.
Okay, yeah.
And then there's 31 ladles, and they want to know the total utensils for all of them. Yeah, exactly.
I got it. Yeah. Thank you.
Okay, cool. Sick. Okay. Analyzing the item, A is without the ladles, C is the answer. Oh, ooh, I like that. So yeah, Zach's going in and like reverse engineering why they put these things, right? Yeah, this is without the ladles. C is the answer if you divide by 10 for the ladles. Wow, that's cool, Zach. I didn't even notice that. Yeah, rather than 20. Hell? And D is the answer if you had 620 to the number of forks and spoons. Wow.
How the hell did you find all that out? What? Yo.
Yeah, he's just going through it. He's just checking it out. Yeah.
What?
Yeah, so if you did 620 ladles, 620 spoons, and 620 forks, you'd get 1860. 620 ladles. Yeah, dude, that's a recipe for like a knife fight, dude. I have a bad time, dude. You get a ladle. Ladle Wars. Okay. Let me see what this says.
Thank
so this
you.
is Odin Root. You're welcome, dude. You're bong coin.
Did you send the picture from yesterday? No, you didn't. Wait. Yesterday we did the
Which one?
updating the index numbers, right?
Index numbers.
Or was that 2 days ago?
Was it this one? The interest?
Yeah.
All right, here, I'll send this to you.
Thank you.
Okay. Find T, end, and kappa for this. Yeah, it is fun to do reverse engineering. Sibley says, I didn't even know what a ladle was. That's too funny. You guys don't know what a ladle is. Okay. I'm gonna guess T is tangent. Is that the tangent vector? And then N is the normal. Oh, that's cool. Sibs bilateral. Bilateral. Sorry. Bilingual.
Bilateral.
Oh, unit tangent, unit normal. Okay, cool. Interesting. So I believe that T is equal. Is this true here, Zach? Is it nabla R divided by I don't know, like the magnitude of nabla R? Is kappa the curvature? Maybe. Zach says yes. That's cool. Yeah. Zach says kappa is curvature, which I'm gonna guess is maybe this. Is this curvature maybe? Second derivative seems to feel like that's what it is. Okay, so let's do this. Wait, but this is a parametric equation. It is related to the second derivative. Yeah, okay. Okay, do I do this with respect to T, Zach? Do I have... I mean, because none of the stuff has X, Y, or Z in it. So I want to bet that this is e to the t sine t plus e to the t cosine t. And then this is just e to the t. Ah, it's not nabla, it's r prime of t. Thank you. That makes more sense. And then this is e to the t cosine t minus e to the t sine t. You're okay. Okay, this is r prime. So this is dr dt. Over dr dt. Where r is a vector. Okay, but then I need the norm, which is this squared plus this squared plus this squared, all square rooted. Oh, so that's a mess. Okay. So this squared is going to be e to the 2t sine squared t plus e to the 2t cosine squared t plus 2e to the 2t sine t cosine t, which I believe this is an identity. 2 sine t cosine t, I think is sine of 2t. We'll see. Okay, and then that's plus e to the 2t, and then plus this one, which is going to be the same thing as what this started, but this is going to be a minus. Yeah. Okay, so then we have plus e to the 2t sine squared t plus e to the 2t cosine squared t minus 2. Oh, so that's fun. So it actually goes away. I don't even need it. E to the 2t sine t cosine t. Love that shit. Okay, that, yes. Beautiful. My pen is like going upwards. Okay, so this goes away. This goes away. And now what I'm left with, this is cool. So this is sine squared plus cosine squared, which is 1. And this is also sine squared plus cosine squared, which is 1. So I have 2 of those e to the 2t's plus another e to the 2t. So that's equal to 3 e to the 2t? Okay. So then it's this all times 1 over 3 e to the 2t. Cool. Which I guess I could pull an e to the t out of all this, right? Let's just pull an e to the t out of everything here. And now you get 1 over 3. But then it's e to the t over e to the 2t. So it's just e to the t on the bottom. And then that's going to be sine t plus cosine t, comma 1, comma cosine t minus sine t. Yeah. I think that's what that is. Oh, sorry, and this is the square root of all this. Oh, I fucked up. Sorry, it's all this, and then it's square rooted. So it's a square root. Oh, so that's square root of 3. Square root of e to the 2t is just e to the t. Oh, very cool. So when I pull an e to the t out, this actually goes away. Oh, very cool. Oh, so it's just 1 over the square root of 3. All this. Wow. Very cool. Yeah. I think I am going to end the stream at this just because I did this one and I'm happy. But apparently, like, to get t... Sorry, to get n, I need to do t prime, I think. So n is equal to t prime normalized by t prime. And then curvature. Oh, very cool. Yep, this is actually this is everything I wanted. Kappa is 1 over RS. Sorry, but what? Oh, sorry, let me show it on the screen, sorry. I see. Okay, cool. So kappa is equal to the magnitude of t prime. Okay. Very cool. Okay, cool. We'll do that next time. I'll end the stream soon. One sec. Question from Red Roach. Why sometimes for integrals you can take the imaginary or real part of the thing, but sometimes you can't? I guess it depends what you're looking for, right? At least in physics, we tend to only concern ourselves with the real part of things, unless we're talking about wave propagation or quantum effects. Then we look at the imaginary part of things. Zach asks, Red Roach, are you doing complex integration? Because... Oh, you mean like sine of x can't be imaginary, for example? I think usually you're equating it to something that only has real components, so you only look at the real components. Oh, I mean, sine of x can be... Oh, it's okay. Sine of x... Well, sine of x can be written as e to the ix. That's called the Euler identity? Euler formula, right? Yeah. Oh, I see. So, yeah, for instance, yeah, you can write it this way. Okay, so, like, I'm solving e to the x sine x integral. I can use that right. Integral of e to the ix minus e to the ix. I think so. I think that's valid. Mm-hmm. So then it just becomes like an exponential integral. Yeah, Sebastian's asking, like... Right, so that's how you write sine. He says he's solving e to the x sine of x, which technically you need to solve using integration by parts. And you have to do it twice. And you have to get it to loop back on itself. Take the Fresnel integral, for example. Wait, what's that one? So I think you're talking about like this. This is a well-known one to do integration by parts. You do it twice, and then you get the original expression, and then you can go back. Yeah, Fresnel. Take the Fresnel equations, for example. Edvin says, can you solve an equation for me? If you ask it in the next 2 minutes, yes. But you need to submit me a screenshot real quick. Here's the website's down there. Do you see that website down there? If you send me a screenshot, I'll do it. But you gotta send it to me quick. Because I was about to go. You can post it in Discord if you want to. Yeah, that's fine. Just join the Discord. Zeno. So let's see. Sebas says, I've seen Maths 505 solve that using differentiation under the integral sign. Okay. Yeah, so like using fundamental theorem of calculus. Or Red Roach says the Feynman technique. Ah. There are a lot of really cool tricks. Feynman was a fucking G, by the way. He's a really cool guy. Or was. I guess he passed, unfortunately. But he also worked at the same place I did. For my undergraduate internship, I worked at Los Alamos doing fusion research. And it was really cool to see that. Like, oh, Feynman was here as well. He's a G. Okay, here we go. Zach's got a little... Okay. Integral from 0 to infinity of cosine of t squared. I'm confused how I should solve this. The answer suggests using is equal to square root of pi over 4. However, I do not understand how I'm supposed to realize that. Any ideas? Oh, okay. Oh, okay. The fancy R is real. I like that. That's cool. Cosine of negative x squared is the real part of that. Oh, okay. Here, I'm going to send this link to Red Roach on... sorry, where's my chat? There you are. Yeah, there you go. There's the Stack Exchange. One sec. I think I got yours, Edvin. Nice. Cool. Yeah, I'll help you with this one, then I'm going to end the stream. But thank you, Edvin, for this question. Let's do it real quick. Yeah, you're welcome, dude. Again, make sure to... Red Roach, if you want to... Zach is another awesome streamer friend of ours. And we have a whole calendar. So here, let me post Edvin's question first. Edvin, I see your question. We're going to do this. Okay. But then... Also, if you ever want to like check out when other people are streaming... we have a whole calendar here that you can go look at, and it'll tell you when people are on. So, for instance, Zach is on again Saturday morning. So Zach's e to the 2i pi. He's the guy that's been helping you. He's very smart math guy. So if you check this Google Calendar thing, it'll have when all the times we're streaming. One second. I need to. Where'd my chat go? There it is. There you go. There's our schedule. All right, let's see, Edvin. If S of t is equal to that, what is S prime of 0? Ooh. Okay. So, this kind of looks like a pain. But maybe it's simple. Let's see if it... I see I can at least pull a 2 out, right? So I have minus 5t minus 7 over 5t minus 3. Does this factor? Let's see. Yeah, I know you can use the product rule and chain rule. I was hoping maybe one of these like cancels with one of these. Let's just check. So factors at 12 would be like 1 and it's positive 12 though. Fuck. Yeah, none of that's gonna. Yeah. Or it could be negative. It needs to add up to -2. -2, -6, -3, -4. Yeah, no. Unfortunately, we can't factor this. Damn. That's unfortunate. Okay, so this just sucks. Okay, so here's what I'm gonna do. I'm gonna call this whole thing A. I'm gonna call this whole thing B. Okay, and I'm just gonna start calculating derivatives. Holy cardio. What's up, Odin? Did you do some cardio? I did your question earlier. So A prime is gonna be equal to 12t minus 2. B prime is a little bit trickier because this is a quotient rule. So let's figure this out. So B prime is equal to the derivative of the top, which is -5, times the bottom, so 5t minus 3, minus the derivative of the bottom, which is 5, times the top, which is -5t minus 7. And then this is all over the bottom squared, which is 5t minus 3 squared. Okay. Oh, those derivatives are cardio. Yeah, exactly. Anirudh says, could you go over security exam? I don't know much about cryptography, unfortunately. Okay. So then with the product rule, right? That's going to be A prime B plus B prime A. So A prime, we already said, was 12t minus 2. And then times B is going to be this. Thank God for copy paste. And then we're going to say plus B prime. B prime is this. Yeah, yeah. Well, this is just annoying, honestly. I don't know if this really teaches you anything. It just teaches you to hate math. Okay. So, that's what this is. This is S prime. I could simplify it, but I'm not going to, because all they care about is S prime of 0. So now I'm just gonna plug in 0 for T, which is nice, because a lot of shit's gonna go away real quick, right? Love that. Okay, this is gonna go away. This goes 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 away. Okay, so let's see what's left in the fallout. So you have a -2 being multiplied by a positive 7/3 plus. All right, we got -5 times -3. That's 15. Minus 5 times -7, so that's plus 35. You crossing out only the linear term is scaring me. Am I not allowed to do that? I think I can. Can I not? I'm pretty sure I can. Or is it just is that one of those things where like I'm committing like math heresy? And then -3 squared, cool, is 9. And then this is times 2. Right? We're just going to assume we're not dividing by 0 anywhere. Okay? Let's just be nice. So, -14/3 plus 50/18. No, 100/18. No. Yes, 100/9. Which, what is that? -42/3/9 plus 100/9, which is 58/9. I think that's the final answer. If we want to check, let me just throw this at ChatGPT. Just so I like to, again, double check. You can't cancel the 5t like that. Evan says it's right. Yeah, okay, yeah. I know technically I'm not allowed to do that, but for basic math things, I think I'm okay. Thank you so much, man. That made so much sense. Fuck yeah, dude. Yeah, again, I should have simplified better, and yeah, there it goes. It says 58/9. Love that. Cool. Yeah, it worked. Yeah, no, if we did this on here, dude, I hate it when ChatGPT fucks up. Like, it can't. Like, what? You couldn't get this last line right? 58/9. Defrac is 58/9. That's LaTeX. Okay, cool. Funny Horse. What's up, Funny Horse? Are you trolling me, Funny Horse, or do you legitimately need questions with this? Are you fucking with me, dude? Because I do have to go to a friend's birthday dinner. If you legitimately need help with this, I will help you. It's okay. There's no such thing as a dumb question. Unless this is some Terrence Howard shit where like 2 + 2 is equal to 5 or something. Okay. Is this yours, Xenos? Is this seriously your question? It's okay. I mean, I'll do it. I mean, this is 6. This is 7. This is 8. This is 9. This is 10. They keep going up, actually. This is kind of fun. This is 7, 8, 9, 10, 8. Nobody. You can post right now if you want. There you go. Did you get me to say 6, 7?
That's dope.
God damn it, dude. Oh, you guys with the 6, 7. Stop, dude. Stop. Okay. Oh, it's in Discord. Oh, sorry. That was another question I was looking at. Oh, my bad. Frogfic. So sorry, dude. I see your question actually now. Sorry, that was someone else trolling me. Okay, and you said a couple questions from them. Sure. Ooh, inequalities. Yeah, cool. All right, I'll do these. These are all right. That was not me. I just heard 6, 7. Okay. Okay, dude. All right, these are yours, Xenos, yeah? Graphing inequalities. So, graphing inequalities is the same as graphing normal things. All you do is you just like have to pick a number to know where to shade, okay? So, for instance, let's do this one, okay? Which is 3y is less than or equal to 4x plus 6. I want to get this in slope-intercept form, so I'm going to divide everything by 3. So that becomes y is equal to 4/3 x plus 6/3, which is 2. And then I'll deal with this later, okay? Just wait. So I just need to graph this, which we should know how to graph 4/3 x plus 2, right? That means I go up 2. That's the y-intercept. And then I go up 4/3, right? So 1, 2, 3, 4. 1, 2, 3, and that's here. Okay. Now what I do is I'm going to draw that line. Well, that's too thick. Thick boy. Okay, there we go. That's better. Okay, this is the line. And then there's something you have to be careful here, Xenos. So if in your inequality it's less than or equal to, if you have that, you're going to draw a solid line. In the case where there isn't an equal sign, so for instance, this is already in slope-intercept form, y equals minus x plus 3. Because this is just this, you need a dashed line. So negative x plus 3 would 1, 2, 3, and then it's just minus 1, right? So, I don't know, probably looks something like this. But that's me like, yeah, like a dashed line is what you want to draw. Okay. So whatever, probably like that, and then you want to go Okay. You need to shade one side of this, right? You have to either shade this side or you got to shade this side. How you figure out which side to shade is you pick a point in that region. Yeah, sure. Yeah, use 0, 0 to test. I love that. Yeah, 0, 0. Let's use it. Plug it back in. Is 0 greater than or equal to 0 plus 6? No, it's not. So 0, 0 does not get shaded.
No.
Okay, so that means we just shade this side. And then you're done. So yeah, you don't want to pick 0, 0, by the way, if 0, 0 is on your line. No, you can just use 0 all the time, as long as your line doesn't go through 0. If your line goes through 0, you can't use it. Then you have to use a different point. I don't know what this means. Isn't that the word for pound? Isn't that like pound sterling? That's like a currency, dog. What? Okay. But what does the pounds? What does that symbol mean in math? Bro, you're pretty buff. Thanks, dog. I did go to the gym today. I did legs. I squatted 225. Not that much. I'm better at chest day than I am leg day, but I don't skip leg day. Okay, let's see this one. I'm curious about this. X minus y is greater than or equal to 4 if x is greater than 0 and y is less than or equal to negative 2. Okay. So I'd rearrange this. I'd move the x over, I'd move the 4 over. So then I get x minus 4 is greater than or equal to y. So y is equal to x minus 4, sure. That's down here. And then that's going up. Oh. The pound in one character set is... It's less than or greater than? Oh, so that means it's less than or greater than 0? Oh, that's cool. I didn't know that. Again, this is an equal sign here. Xenos. Right? So... That means... Oh, we had 1,800 followers today. Sick. I didn't realize that. Nice. The big 1-8. I gotta set a new goal for us. We had 1,800. That's super cool. Okay, and then they say x is greater than 0. So that means you're only shading this part, right? Well, okay, first of all, let's find a test point. Let's pick 0, 0. Is 0 greater than or equal to 4? No.
No.
Okay. Yeah, submit a screenshot text if you want. Use the website. There's a website down there. Okay, so 0, 0 does not work. So I know it has to be here, but now we have other conditions. X has to be greater than 0, right? So that means this area is off limits, right? Because I need X to be greater than 0. Okay, so we already know here has to really be it. And then also Y must be less than or equal to negative 2. Okay. So negative 2 for Y would be here, and it has to be less than that. So I think this is your region, but then this one I believe is dashed. That's cool. It's like a double region, I think. So this right here is the X is greater than or equal to 0, right? X is greater than or equal to 0 is like everything over here. And then you're just finding the intersection of all the inequalities. Okay, so this is your super happy region. It's all this. Yeah. We're not cooks like you. Okay, cool. Is that the answer? I think that is the final answer, man. Yeah, I think it is. Yeah. No, these are still inequalities, though. These are still inequalities. You just have to get the intersection of all three things. So it has to be y has to be less than or equal to x minus 4. So that tells you it's down here somewhere. You also know y has to be less than negative 2, so it has to be even further down. And then x has to be greater than 0. So, yeah. This one write the linear inequality statement. Well, I assume this is the graph. So 0, 0 has to work, right? 0, 0 works. 0 is something. 5, that's if it's less than 5. Right? So this would be y. Sorry. Y is less than x over 2 plus 5. You can also see because this is dashed. See how this is dashed? Dash tells me it's not less than or equal to. And then I know it's less than because it's... You can also see because it's below. Like, it's below the line. Same thing for this one. This would be a below one. If you get it in the slope-intercept form first. All right, this one. Write an algebraic statement to represent each inequality. Okay. I always like to think about... I put like the variable on the left, and then the arrow is just which way it's going. So this is an open circle, so I know it's going to be not an equal sign, okay? But it starts at -6. Cool. So something with -6. So x does something with -6. The arrow is going to the right, so I'm going to do this. And then you're done. This one, it's something with 9. It's solid, so we're going to have an equal sign in there. And it's pointing to the left, so this is less than or equal to 9. Same thing for this one. X, something with -3. It's hollow, but it's going to the left, so this is just less than -3. Yeah. So that's how to do those. This one's kind of a mess. This reminds me kind of what Zach was doing today on his stream. Just beat it to death. Wait, there's a... What's the pound symbol? Wait, what? Oh, here it is. So wait, what do they say it is? Oh, on the Mac keyboard, this is option -3, which is option shift 3. Oh, so it's a typo? That's too funny. What's up, Zhangju? Okay. So here, I don't like fractions. So I'm going to multiply everything by like the biggest denominator, which in that case is 10. Okay. So if I multiply everything by 10, which you can do, this becomes 20 over 5, which is 4. So I'm going to have 4x minus 3. 10 times 1 over 10 is 1. As long as you multiply by a positive number. Times 30 over 2, which is 15. 3 minus 2x. Okay. So, now I can do some manipulation. So 4x minus 12 plus 1 is less than 45 minus 30x. Let's add, let's subtract. 34x is less than 56. It's kind of ugly. Really? Did we do that right? Sorry. I'm getting tired. This type of tedious algebra is all over calculus. It is. These are like foundational things which are very important to know in order to do calculus. I mean, it's kind of like a pre-calc thing, I guess. Because, yeah, if you don't know this, you're going to start, like, floundering. But I do agree, it is fucking tedious. I'm sure I'm making a mistake somewhere, too. Yeah, plus 1156. I think that's right. Okay. Yeah. Yeah, they're pre-calc. Yeah, definitely. Okay, so x is less than 56 over 34, which, I don't know, it's like 1.9-ish. Oh, 28 over 17. That is cool. Okay, fine. 28 over 17. I don't know. We can pull out a calculator if you want to. 28 divided by 17, 1.64. Okay. So here, what? You would put like 0, 1, 2. Put a hollow line here, or right, hollow. And then again, if you ever want to see which way it goes, just always make sure the variable's on the left. And wherever this points, this points. So then this is going to point in this direction. And then you're done. Okay. Cool. I don't have time to do all the rest of these, Frog Thick. But if you want, I'll do these on the next stream. Just because, yeah, I'm getting a little... I'm like seriously late for a birthday party now. I think I've gotten like a little bit late. What's up, Skeeg? Good to see you, bro. Dot says implicit differentiation. I have a very good video on implicit differentiation. Yeah, long time no see, dude. Yeah, I've been streaming for a bit. I mean, we've hit almost 3 hours right now. Yeah, I'm glad it helped. If you want, Frog Thick, I will probably stream on... When is this due? Like, when do you have a test? When do you have something coming up that requires this? Because if you want... these are really good questions, and they help other students if I go through them. I'm getting tired. Too funny, though, if you want to look at, like, how my stream analytics are working on... oh, you got a full year for it? Oh, fuck yeah. Okay, then cool. Yeah, come by my next stream. I'll do it. I definitely do Calc 1. These have been my analytics, dude. It's too funny. Fuck you, algorithm, dude. Like, what? Like, we hit, like, pretty high number of viewers on the live stream early. And then this, and then, like, complete, like... This is when I was going to end the stream. I was going to end the stream here. This is at, like, the 2-hour mark. And then it just started climbing again. I'm like, damn it. I don't want to keep streaming. I have to go. But fuck you, algorithm. Anyways, I do Calc 1. I do everything. Besides like the really obscure like engineering shit. Like someone asked me something about like MOSFETs earlier. I was like, yeah, no. But it is stochastically. Yeah, there's a stochastic. So yeah, if you want to get more help, please make sure to either like subscribe, whatever. We're streaming on 4 different platforms right now. So whatever platform you're on, sub, like, subscribe, and you'll get a notification when I stream again next, which I do pretty regularly, and I'm thinking about increasing it more, just to like really help you guys out because we're getting a lot of stuff. But if you ever want to get like a live calendar of when we stream, there's a website here, and that'll tell you the next time we stream. So Zach will have a math stream on Saturday. I will probably put another one here on Sunday, just because I see the demand for it. Okay. All right, that being said, let's close out the stream. Thank you, everyone, for coming, Actual Education Officers. I really appreciate it. Thank you for all your questions, insight, all the love. Super awesome to see you guys here. Our next stream will be, it's technically going to be on Monday. I might do one on Sunday. Just stay up to date with that calendar, and we'll be there. Yes. If you're finding us on TikTok, any of the, just follow, and I'll have more time for you guys during the next stream. Cool. All right. That being said, if you're following us on Twitch, type shit. Yeah, you're welcome, Sib. We're going to go raid somebody on Twitch. Go say hi to... Support another streamer. We have so many awesome streamers that... I'm not the only person that does this. There are many people that do this. And we like to support them. Where's... Sorry, raid channel? Where's, like, people... Did they get rid of this? Did they get rid of the... I can see who I follow? What? What the hell? Dude, look at Zach. What the fuck? I have to raid by similar or smaller size? What? Where's like people I follow? Oh, these people are terrible, dude. What? Twitch, piece of shit. They're always changing Twitch. Okay, who's on? Twitch. Moo Hoodles is on. Okay, who's on? Okay, cool. All right, we're gonna go raid Moo. Moo Hoodles. Yeah, she's cool. She does like Astro stuff. Nice. All right, go say hi to Moo Hoodles. Enjoy the rest of your week. Enjoy the weekend. We will see you guys on either Sunday, but definitely Monday. Peace.
Different